The Big Bang did not bang. There was no explosion, no sound, no flash of light illuminating an infinite void. The beginning of everything was actually silent. In the emptiness before time, in a place without space, something happened that defies our language, our imagination, and every evolutionary instinct that shapes how we perceive reality. You've been told a story about the universe's birth that fits neatly into human understanding, but the truth is far stranger. What if everything you think you know about cosmic origins is merely a comfortable fiction, a simplified tale we tell ourselves because the reality is too alien, too incomprehensible for minds evolved to track predators on ancient savannas, not contemplate the birth of dimensions themselves? Look up at the night sky. That ancient light streaming down from distant stars tells a story. But it's not the whole story. It's not even close. The universe you perceive is a shadow, a thin slice of something far more vast and bewildering. When you look outward through your telescopes, you're not seeing reality as it is. You're seeing reality as it appears to creatures trapped in 3 dimensions of space and 1 of time. Like inhabitants of flatland trying to comprehend a sphere, we glimpse only cross-sections of a greater whole. The cosmos doesn't just exist. It exists in ways your brain was never equipped to process. The question isn't just why the universe looks the way it does. It's why you're only able to see it this way, through the narrow keyhole of human perception. Time itself is suspect. You experience it as an arrow, flying relentlessly forward, creating a neat division between past, present, and future. But at the fundamental level of reality, this distinction disappears. Past and future exist simultaneously. Time doesn't flow, it simply is. The universe doesn't unfold moment by moment like frames in a film reel. Rather, it exists all at once, complete from beginning to end, a single mathematical object stretching across all epochs. Your sensation of the present moment moving forward is not a fundamental property of the cosmos. It's a peculiarity of consciousness, an illusion generated by your brain. If you could step outside the constraints of your perception, you would see time not as a river, but as a landscape, every moment that ever was or will be, existing eternally. Consider for a moment what it means if all of time already exists. Your birth, your death, this very thought arising in your mind as you hear these words. All predetermined points in an unchangeable cosmic sculpture. Every choice you think you're making has already been made. The future isn't unwritten. It's simply unvisited by your consciousness. This isn't fatalism. It's physics. The equations that govern our most successful theories don't distinguish between past and future directions. They describe a universe where time is just another dimension, no different in kind from up, down, left, or right. Your intuitive sense that time is flowing, that the future is open and undetermined, may be nothing more than an evolutionary adaptation, a useful fiction that helped your ancestors survive, but that bears little resemblance to fundamental reality. But if time isn't what we think, neither is space. The seemingly empty void between galaxies, stars, and atoms isn't empty at all. It's a roiling sea of virtual particles blinking in and out of existence, a quantum foam of possibilities governed by probability rather than certainty. What appears to be nothing is actually everything. All possibilities superimposed until observation collapses them into definite states. The vacuum of space isn't an absence. It's a plenum, teeming with potential energy and ephemeral particles. Even more disturbing is the possibility that space itself isn't fundamental but emergent, a holographic projection from information encoded on a distant boundary. The 3-dimensional world you experience could be an elaborate illusion, a volumetric rendering of data that actually resides on a two-dimensional surface, like a hologram. You might wonder why this matters. If the cosmos appears consistent to our observations, why should we care about what lies beyond our perceptual limits? Because what we can't see shapes what we do see. The visible universe, all the stars, galaxies, and nebulae captured by our most powerful telescopes, accounts for just 5% of what must be out there according to our equations. The rest? Dark matter and dark energy. Invisible influences that determine the fate and structure of everything visible. They bend light, shape galaxies, and drive the accelerating expansion of space itself, yet they remain ghostly participants in cosmic evolution, detectable only through their gravitational effects. You're living in a universe where 95% of reality is invisible to you, exerting forces you can't directly perceive. Every galaxy you see is embedded in a vast halo of dark matter, shaped by its unseen hands. Imagine walking through a forest where you can see only the leaves, while the branches, trunks, and roots remain invisible. You'd develop theories about floating green patches, never understanding the true structure supporting them. This is our predicament when trying to comprehend cosmic architecture. We observe galaxies arranged in vast filaments and superclusters, forming a cosmic web that stretches across billions of light-years, but we can't directly see the dark matter scaffolding that dictated this arrangement. The universe looks the way it does because of what we can't see, not just what we can. And what about the big question? Why is there something rather than nothing? The very existence of reality demands explanation. Every atom in your body, every photon of light, every cubic centimeter of space, none of it had to be. Yet here it all is, persisting moment after moment. Physics can describe with astonishing precision how the universe evolves over time, but it stumbles when attempting to explain why there's a universe at all. Some theorists suggest that nothing is inherently unstable, that the void itself contains the seeds of existence, that quantum fluctuations in absolute emptiness can spawn entire universes. Others propose that the question is meaningless, that nothing is not a state that could ever have existed, that being is necessary, not contingent. But these answers only push the mystery back a step. Why these physical laws that permit existence rather than none at all? Why a cosmos that allows for quantum fluctuations, for mathematics, for logic itself? The enigma deepens when we consider how exquisitely calibrated our universe appears to be. The fundamental constants of nature, the strength of gravity, the IU charge of an electron, the mass of a proton, all seem precisely tuned to allow for complexity and life. Adjust any one of these values by a fraction of a percent, and stars couldn't form, atoms would be unstable, or matter couldn't clump together to form structure. Is this apparent fine-tuning evidence of purpose, a cosmic fingerprint of design, or is it a selection effect? Are we only here to ask these questions because we happen to exist in one of the exceedingly rare universes where the constants permit our existence? If countless other universes exist with different physical laws, most barren of complexity or consciousness, our amazement at our universe's hospitality would be like a lottery winner expressing shock at their good fortune without considering all the losing tickets. This brings us to perhaps the most vertigo-inducing possibility of all, that our universe is merely one of many, a single bubble in an infinite cosmic foam. The Multiverse Hypothesis proposes that what we call the universe is just an infinitesimal fraction of reality, one variation among an endless array of cosmic permutations. In some versions of this theory, every physically possible universe exists somewhere in the greater multiverse. In others, Every quantum possibility branches into its own separate reality, creating new universes with each event. Imagine. Each time a particle's position is measured, each time a quantum coin flip resolves, reality doesn't collapse into a single outcome. It splinters, creating parallel worlds where each possible result occurs. If true, there are versions of you who made different choices, who followed paths your consciousness never experienced, living lives that branched from moments of quantum chance. The multiverse isn't just a philosophical curiosity, it emerges naturally from some of our most successful physical theories. Inflationary cosmology suggests that the explosive expansion that launched our observable universe continues eternally in other regions, spawning new cosmic domains with potentially different properties. String theory, in its attempt to reconcile quantum mechanics with gravity, mathematically requires extra dimensions and predicts a vast landscape of possible universes with different physical laws. These aren't the fantasies of science fiction, but the sober conclusions of equations that otherwise accurately describe the world we observe. But this cosmic plurality comes with a price. It threatens to undermine the very enterprise of explanation. If every possible universe exists, why bother explaining why ours has the properties it does? Any feature of our cosmos, no matter how unlikely or bizarre, could be dismissed as a random selection from infinite possibilities rather than the product of underlying principles. The multiverse hypothesis risks becoming a theory of anything, with little predictive power. Yet we can't dismiss it merely because it complicates our quest for explanation. Reality isn't obligated to conform to our desire for simplicity or comprehensibility. The universe doesn't just challenge our understanding, it challenges the very notion that understanding is possible. Consider the paradox of quantum mechanics, where particles exist in superpositions of states until measured, where cause and effect blur, where complementary properties like position and momentum can't be simultaneously known with precision. After more than a century of work by the brightest minds on the planet, we still have no consensus on what quantum theory actually means about the nature of reality. Does the act of observation create reality? Do infinite parallel worlds branch off with each measurement? Is there a deeper level of reality with hidden variables that would restore classical intuition if only we could access them? The mathematics works perfectly, predicting experimental results with unprecedented accuracy, but the interpretation remains shrouded in mystery. This quantum strangeness isn't just academic. It's fundamental to why the universe looks the way it does. Without quantum mechanics, stars couldn't shine, DNA couldn't replicate, and solid matter as we know it couldn't exist. The elegant dance of probability waves that defies our classical intuition is precisely what enables the complexity we observe. At larger scales, your very ability to contemplate these mysteries depends on quantum effects in the atoms of your brain. You are not just in the universe, you are of it, composed of the same quantum weirdness you struggle to comprehend. What does this tell us about reality? Perhaps that the gap between what exists and what we can comprehend is not a temporary shortcoming of our theories, but a permanent feature of consciousness itself. Our brains evolved to navigate the savannah, to track prey and avoid predators, to cooperate and compete with other humans, not to understand quantum fields or 11-dimensional brains. The neural architecture that serves us so well in daily life may be fundamentally inadequate for grasping ultimate reality. The universe may not just be stranger than we imagine, but stranger than we can imagine. Yet despite these limitations, we've managed to peer further into the cosmos than our ancestors could have dreamed possible. We've detected gravitational waves from colliding black holes billions of light-years away, confirmation of ripples in the very fabric of space-time predicted by Einstein a century ago. We've mapped the cosmic microwave background radiation, the afterglow of the Big Bang, revealing the state of the universe when it was just 380,000 years old, a mere infant in cosmic terms. We've discovered thousands of planets orbiting other stars, worlds of staggering diversity, from gas giants with rings more spectacular than Saturn's to rocky worlds not so different from our own. Our vision has extended across 13.8 billion years of cosmic evolution, from the first moments after the Big Bang to the complex galactic structures of today. But this expanded vision has revealed as many mysteries as it has solved. The more we see, the more we realize how much remains hidden. Take dark energy, an invisible force causing the expansion of the universe to accelerate rather than slow down as expected. Discovered only in 1998, this mysterious energy constitutes about 68% of everything that exists, yet we have almost no idea what it is. Its strength appears to be perfectly calibrated. If it were slightly stronger, it would have ripped apart. Cosmic structure before galaxies could form, slightly weaker, and the universe would have recollapsed long ago. We live, against seemingly impossible odds, in a universe where dark energy is just powerful enough to accelerate expansion without preventing complexity. Or consider the cosmic horizon, the limit of what we can theoretically observe. Because light travels at a finite speed, and because the universe has a finite age, we can only see objects whose light has had time to reach us since the Big Bang. This creates a cosmic horizon, roughly 46 billion light-years in radius. What lies beyond? We can never know, even in principle. The accelerating expansion of space ensures that regions beyond our current horizon will never come into view. In fact, galaxies we can see today will eventually slip beyond the horizon, their light stretched by expanding space until it becomes undetectable. The observable universe is not just limited by our technology, but by the fundamental structure of spacetime itself. And what of the beginning? Our observations can only take us so far back in time before the conditions become so extreme that our current physics breaks down. We can trace cosmic evolution back to a fraction of a second after the Big Bang, when the universe was a seething plasma, trillions of degrees hot. But the actual moment of origin, if such a moment even meaningfully exists, remains shrouded. The singularity predicted by general relativity, a point of infinite density and zero volume from which spacetime itself emerged, likely indicates not an actual physical state, but the failure of our theories at extreme scales. Quantum gravity, a still undeveloped theory that would unite Einstein's relativity with quantum mechanics, might reveal what happened at the very beginning. Or it might show that the concept of a beginning is itself an artifact of our limited perspective. Perhaps our very notion of beginning is tied to our experience of time as flowing from past to future. But if time is an emergent property rather than a fundamental one, if the distinction between past and future dissolves at the quantum level, then asking what happened before the Big Bang might be as meaningless as asking what's north of the North Pole. The beginning of our observable universe might not mark the beginning of everything, but merely a transition, a phase change in a much larger, perhaps eternal, reality. Some cosmologists propose that our universe emerged from the collapse of a previous one, part of an endless cycle of expansion and contraction. Others suggest it bubbled off from a parent universe, one of many such births in an eternal inflation scenario. Still others wonder if time itself is circular rather than linear, with the future eventually looping back to what we call the past, eliminating the need for any beginning at all. These aren't just wild speculations. They're serious attempts to reconcile our observations with mathematical models that don't break down at extreme conditions. And each possibility forces us to reconsider what we mean by universe and existence. Your Intuition rebels against these possibilities because it was shaped in a tiny corner of reality, at scales where Newtonian physics reigns supreme, where time seems absolute, where space appears fixed, and where quantum effects average out into classical predictability. But venture beyond this comfortable domain, into the very fast, the very massive, the very small, or the very energetic, and intuition becomes not just unreliable, but actively misleading. The universe you intuitively understand isn't the universe that actually exists. It's a simplified model, a cognitive approximation that worked well enough for your ancestors to survive and reproduce. So why does the universe look the way it does? Perhaps it doesn't. Perhaps what we perceive as the cosmos is merely the shadow of a higher dimensional reality projected onto the screen of our limited perception. Perhaps the very question assumes a privilege our species doesn't possess, that the way things appear to us bears some special relationship to the way they actually are. Our senses evolved to detect threats and opportunities in the environment, not to perceive fundamental truth. The world presented by our eyes, ears, and measuring devices is already filtered, interpreted, constructed, not a direct apprehension of reality, but a useful model of it. Consider color. The rainbow you perceive doesn't exist out there, electromagnetic. Radiation has wavelengths, not hues. Color is created by your visual system as a way of representing those wavelengths, a biological convention rather than a fundamental property of light. Similarly, perhaps the distinct objects you perceive, stars, planets, galaxies, atoms, are mental constructs imposed on a reality that's actually a seamless whole, undivided by the boundaries our minds create for convenience. The separate things you observe in the universe might be as much a product of your cognitive architecture as the colors you see. The ancients looked at the night sky and saw constellations, bears, hunters, scorpions, imposed on random distributions of stars. We now know those patterns were psychological projections, not cosmic designs. What patterns are we still projecting? What constellations of thought constrain our understanding of the cosmos? The division between matter and energy? Between waves and particles? Between past, present, and future? Between something and nothing? Each of these distinctions might someday seem as arbitrary as the boundaries of Ursa Major. The very fact that the universe appears comprehensible at all is perhaps the greatest mystery. As physicist Eugene Wigner noted in his famous essay, The Unreasonable Effectiveness of Mathematics in the Natural Sciences, there is no obvious reason why the cosmos should be describable by elegant mathematical equations. Why should the same abstract patterns that human minds can contemplate govern the behavior of galaxies and atoms? Is mathematics discovered or invented? Are the regularities we observe properties of reality itself, or merely features of the maps we create to navigate it? When we find a beautiful equation that perfectly predicts experimental results, have we glimpsed something fundamental about reality, or have we merely created a useful model that happens to work within our limited domain of observation? And what of the observer? Quantum theory suggests that the act of measurement, of observation itself, plays a crucial role in determining reality. The classic double-slit experiment demonstrates that particles behave differently when observed than when unobserved, as if they somehow know they're being watched. Does consciousness itself play some role in the manifestation of reality? Or is the apparent observer effect merely the result of macroscopic measuring devices inevitably disturbing microscopic systems? The universe looks the way it does in part because we're looking at it. But how deep does this relationship go? Some theorists have proposed that consciousness and reality are more fundamentally entwined than our scientific tradition has supposed. The participatory anthropic principle suggests that observers are necessary for the universe to exist, that in some sense, quantum possibilities remain in superposition until brought into definite being by conscious observation. Others see this as mystical overreach, arguing that decoherence, the process by which quantum systems interact with their environment, produces the appearance of wave function collapse without requiring conscious observers. But even this more, conservative view acknowledges that the line between observer and observed is not as clear-cut as classical physics assumed. You don't stand apart from the universe, examining it objectively from outside. You're embedded within it, composed of the same materials, and governed by the same forces you seek to understand. This entanglement of observer and observed creates a kind of cosmic hall of mirrors, where every attempt to understand the universe is also the universe attempting to understand itself through you. Your consciousness, arising from the complex arrangement of matter and energy in your brain, is the cosmos becoming aware of its own existence. When you contemplate the stars, it is star stuff contemplating stars, the universe looking at itself, through eyes evolved from the same primordial elements forged in stellar furnaces billions of years ago. This self-reference adds another layer of complexity to the question of why the universe appears as it does, because appearance itself implies a relationship between reality and observer that may be more fundamental than either component alone. The desire to know why the universe looks as it does might itself be a feature programmed into the cosmos, a way for reality to explore its own nature through conscious subsystems like yourself. Your curiosity about the fundamental nature of existence isn't separate from the phenomena you're investigating. It's part of the same cosmic process, another expression of the underlying patterns that generate both galaxies and the minds that contemplate them. In this sense, your questioning isn't just about the universe, it is the universe, doing what it apparently does, creating systems of increasing complexity that can reflect upon their own conditions. But if consciousness is the universe's way of knowing itself, it's a knowledge that comes with built-in limitations. The tools you use to investigate reality, perception, language, mathematics, logic, are themselves products of the system they're trying to describe. This creates an inevitable circularity. You can never fully step outside the universe to see it objectively, because your very means of seeing are part of what you're trying to see. It's like trying to taste your own tongue or see your own retina. The instrument of investigation can never fully investigate itself. This doesn't mean the enterprise is futile. Far from it. Each new discovery, each deeper layer of understanding, revealed by science, brings us closer to comprehending the cosmic architecture. But it does mean that the answer to why does the universe look like this will always be partially shaped by who's asking and how they're able to perceive. The ultimate nature of reality may be like the horizon, something we can approach but never reach, with each step forward revealing new territories beyond. Consider the revolutionary discoveries of the past century: quantum mechanics, general relativity, the expanding universe, black holes, dark energy. Each breakthrough has not only answered existing questions, but revealed entirely new ones we couldn't have previously formulated. Science doesn't proceed toward some final theory that will explain everything once and for all. It's an endless process of refinement, with each new level of understanding opening vistas of previously unimagined complexity. Today's mysteries, quantum gravity, dark matter, the nature of consciousness, aren't simply gaps that will be filled to complete a cosmic puzzle. They're gateways to whole new puzzles whose shapes we can't yet envision. The universe appears inexhaustible in its complexity, not because it contains infinite actual detail, but because each level of reality operates according to principles emergent from, but not reducible to, the levels below. Just as the rules of biology cannot be derived solely from chemistry, even though living things are made of chemicals, the patterns of cosmic structure may have their own emergent logic, not predictable even with perfect knowledge of fundamental particles. The reductionist dream that understanding the smallest components would automatically yield understanding of the whole has proven naive. The universe looks the way it does not just because of what it's made of, but because of how those components organize themselves across multiple scales, from quantum fields to conscious minds. What if the question itself, why does the universe look like this, contains a hidden assumption that limits our understanding? It presupposes that the cosmos could have been otherwise, that its current configuration is one possibility among many. But what if the universe we observe is the only logically possible universe? What if the mathematical structures underlying reality aren't arbitrary but necessary, the only consistent solutions to some deeper equation we haven't yet glimpsed? Several theoretical approaches, from certain interpretations of string theory to Max Tegmark's mathematical universe hypothesis, suggest that physical reality is ultimately mathematical structure, not merely described by mathematics, but actually identical with it. In such a view, asking why the universe has the properties it does would be like asking why a circle is round. It couldn't be otherwise without ceasing to be what it is. Alternatively, what if our universe is just one of countless mathematical structures, all of which exist with equal reality? In Tegmark's ultimate ensemble theory, every mathematically consistent structure exists as a physical reality somewhere in the multiverse. The question then shifts from why does the universe look like this to why do we find ourselves in this particular mathematical structure rather than another? And the answer would involve anthropic selection. We can only exist in universes whose mathematical structure permits consciousness. So we shouldn't be surprised to find ourselves in such a universe, however rare it might be among all possible structures. But there's yet another possibility, that the very concept of why belongs to the realm of human thought and may not apply to ultimate reality. We evolved to think in terms of causes and effects because identifying causal relationships aided survival. Knowing that certain berries cause illness or that certain cloud patterns precede storms had obvious evolutionary advantages. This causal thinking is so deeply ingrained that we automatically apply it to everything, including the cosmos itself. But what if the universe simply is, without a why? What if existence itself is brute fact, neither requiring nor admitting of explanation? This doesn't mean giving up on understanding how the universe works, the patterns, regularities, and structures that science reveals. But it might mean accepting that the question of ultimate causation or purpose lies beyond what even a completed science could address. The universe looks the way it does, at least in part, because the question is being asked by creatures who evolved within it, whose perceptual and cognitive systems were shaped by its properties, who are composed of its elements and governed by its laws. And yet, paradoxically, we've managed to discover aspects of reality far removed from everyday human experience. Curved space-time, quantum uncertainty, cosmic inflation. Our minds, products of this universe, have somehow developed the capacity to transcend their evolutionary origins, to contemplate realities no human ancestor ever needed to understand for survival. This capacity for abstract thought, for mathematics, for seeing beyond appearances to underlying principles, suggests that while our perception is limited, our understanding need not be bounded by those same limitations. Perhaps the most profound insight modern physics offers isn't a particular theory, but a meta-level observation. Reality is both simpler and stranger than our intuitions suggest. Simpler, in that a relatively small set of mathematical principles can generate the astounding complexity we observe. Stranger, in that these principles often defy visualization or intuitive understanding. The universe we inhabit seems to occupy a sweet spot between logical necessity and radical contingency, structured enough to be comprehensible, varied enough to be interesting. It looks the way it does because it exists at the fertile intersection of order and chaos, where complexity can emerge and persist. As you gaze up at the night sky, watching ancient light from distant stars filter through Earth's atmosphere, remember that your perception of that spectacle involves a remarkable series of translations. From quantum events in stellar cores, to photons traveling across interstellar space, to chemical reactions in your retina, to electrical signals in your visual cortex, to the subjective experience of starlight. Each step in this chain involves models and approximations, filters and interpretations. The universe doesn't just exist, it exists in relationship to you, the observer. And you exist in relationship to it, your very atoms forged in the nuclear furnaces of long-dead stars. This mutual entanglement of observer and observed, this cosmic circularity where star stuff evolves to contemplate stars, may be the deepest answer to why the universe appears as it does. It looks this way because it has evolved observers who can see it this way. And those observers, in turn, have evolved because the universe has properties that allow for complexity and consciousness. The answer to why does the universe look like this may ultimately be because otherwise no one would be here to ask the question. Yet this anthropic reasoning, while logically sound, feels incomplete. It explains why we find ourselves in a cosmos compatible with our existence, but not why such a cosmos exists at all, nor why it has the specific properties it does, rather than others, that might also permit observers. The search for deeper explanations continues, driving scientific investigation into ever more fundamental layers of reality. And perhaps that ongoing quest, that endless exploration of cosmic mysteries, is itself part of the answer. Perhaps the universe looks the way it does, partly to evoke wonder, to stimulate curiosity, to beckon conscious beings toward greater understanding. This is not to suggest conscious design or purpose in a traditional sense, but to recognize that the property of being comprehensible, of revealing patterns that reward investigation, is itself a remarkable feature of our cosmos. A universe of pure chaos would permit no understanding. A universe of trivial simplicity would invite no questions. Ours exists in the fertile middle ground, complex enough to sustain endless inquiry, orderly enough to yield genuine insights. Whether this balance is coincidence, necessity, or something else entirely remains an open question, perhaps the ultimate open question. As we peer deeper into the cosmos with each new generation of telescopes, as we probe the fundamental structure of matter with increasingly powerful particle accelerators, as we develop more sophisticated mathematical models and computational simulations, we continue this ancient quest to understand why reality appears as it does. Each answer reveals new questions. Each horizon crossed reveals new horizons beyond. And in this endless journey of discovery, in this cosmic conversation between the universe and the conscious beings it has spawned, perhaps we glimpse not just what the universe is, but what it's becoming. A reality that knows itself, that evolves not just physically, but in the realm of understanding, as consciousness illuminates previously dark corners of existence. The universe looks the way it does, because it's still becoming what it will be, and you, contemplating these cosmic mysteries, are part of that becoming, a node of awareness through which the cosmos reflects upon itself, a participant in the greatest story ever told, the universe waking up to its own existence. In your questions, in your wonder, In your desire to understand why things are as they are, you're fulfilling one of reality's most remarkable potentials, the capacity to know itself. And that, perhaps, is the deepest answer of all. Let's begin with something you think you know. The universe is expanding. This fact, this cornerstone of modern cosmology, seems straightforward enough. Like a balloon inflating, space itself stretches, carrying galaxies along for the ride. The farther a galaxy is from us, the faster it appears to recede. Edwin Hubble discovered this in 1929, and it's been the bedrock of our cosmic understanding ever since. It's taught in schools, depicted in documentaries, accepted as fundamental truth. But what if this expansion isn't what we think it is? What if the very fabric of reality is doing something far stranger than simply getting bigger? Consider this peculiarity. The universe has no center. When we say it's expanding, we don't mean it's exploding outward from a point. Every galaxy appears to be moving away from every other galaxy, as if each one were at the center of the expansion. This is possible only if space itself is stretching. But stretching into what? We instinctively imagine cosmic expansion as occurring within some larger container, some metaspace into which our universe grows. But there is no container. The universe isn't expanding into anything. It's all there is. There's no outside for it to expand into. Already our intuition stumbles, unable to grasp what the mathematics describes so precisely. The expansion itself holds another mystery. It's accelerating. Since 1998, we've known that the cosmic expansion isn't slowing down as expected. It's speeding up. Imagine throwing a ball into the air and watching it move upward faster and faster, defying gravity rather than succumbing to it. That's what the universe is doing, and it makes no intuitive sense. Something, we call it dark energy, is pushing space apart, overwhelming gravity's pull on the largest scales. But here's the deeper mystery. The strength of this dark energy, the cosmic pushing force, appears bizarrely, improbably fine-tuned. If it were slightly stronger, it would have ripped apart cosmic structure before stars and galaxies could form. Slightly weaker, and the universe would have recollapsed long ago. The observed value of dark energy is at least 120 orders of magnitude smaller than quantum theory predicts it should be. A discrepancy that physicist Leonard Susskind called the worst theoretical prediction in the history of physics. This isn't just a minor mismatch between theory and observation. It's an abyss, a chasm so vast it suggests we're missing something fundamental about how reality operates. Imagine measuring the height of Mount Everest and being off by a factor. Not of 2 or 10 or 1,000, but by a number larger than all the atoms in the observable universe. That's how wrong our theories are about the energy of empty space. And yet, despite this colossal theoretical failure, the universe itself hums along perfectly, balanced on a knife edge of possibility that allows for structure, complexity, and life. It's as if reality is whispering a secret our equations can't quite hear. Let's dive deeper into what the universe looked like in its infancy. We often hear that the early cosmos was hot, but this fails to capture the sheer violence of primordial reality. The infant universe wasn't merely hot. It was a cauldron of pure energy so intense that matter as we know it couldn't exist. Its temperature is really just a measure of how fast particles move. But in the first moments, there were no particles, only raw potential sizzling in a soup of quantum fluctuations. The distinction between matter and energy, between stuff and the motion of stuff, hadn't yet crystallized from the primordial haze. It wasn't just that the early universe was a furnace. It was a state of being where the very categories we use to understand reality, particles, forces, even cause and effect, were still taking shape, still learning to be themselves. The evidence for this primordial state comes from the cosmic microwave background radiation, the oldest light in the universe, released when the cosmos was just 380,000 years old. This ancient radiance surrounds us in all directions, a fossil imprinted on the sky. But calling it a background diminishes what it truly is. It's the surface of a cosmic time horizon, the visible edge of the observable universe. When you tune an old television to static, about 1% of that snow is actually primordial radiation left over from the Big Bang. You're literally seeing the afterglow of creation, photons that have been traveling across the cosmos for 13.8 billion years, only to end their epic journey in your living room. The static on your screen is time made visible, the echo of cosmic birth. This cosmic microwave background radiation appears remarkably uniform, the same temperature in all directions, varying by only 1 part in 100,000. This uniformity presents a puzzle that strikes at the heart of cosmic history. Regions of the sky opposite each other are too far apart to have ever been in causal contact. Light hasn't had time to travel between them in the entire history of the universe. So, how did they reach the same temperature? It's as if two people on opposite sides of the Earth somehow agreed on what clothes to wear without ever communicating. This horizon problem forced cosmologists to propose a solution as elegant as it is mind-bending: cosmic inflation. Inflation theory suggests that the universe experienced a period of exponential expansion in its first fraction of a second, growing from subatomic size to astronomical scales in less time than it takes light to cross an atomic nucleus. During this brief but violent stretching, regions that were once in contact with each other were wrenched apart faster than light itself, eventually becoming the opposite horizons of our observable universe. Imagine taking a photograph and enlarging it a trillion times in a billionth of a billionth of a billionth of a second. That's inflation, a growth spurt of literally unimaginable proportions. But inflation isn't just an ad hoc solution to the horizon problem. It makes predictions confirmed with stunning precision by observations of the cosmic microwave background. The tiny temperature variations in this ancient light, just 1 part in 100,000, form a pattern that matches exactly what inflation theory predicts. Quantum fluctuations, microscopic ripples in the fabric of spacetime, stretched to cosmic scales by the inflationary expansion. These primordial ripples became the seeds of cosmic structure, the blueprint from which all galaxies would eventually form. What began as quantum jitters ended as the cosmic web of galaxies we see today, a direct connection between the smallest scales. Physics knows, and the largest structures in existence, yet inflation itself remains mysterious. What caused it? What stopped it? The field theorized to drive inflation, the inflaton, remains hypothetical, its properties largely unknown, and inflation's most provocative implication, that our observable universe might be just one bubble in an eternally inflating cosmic foam, pushes us toward the dizzying precipice of the multiverse. If inflation is correct, and the evidence strongly suggests it is, then our entire observable universe, all 92 billion light-years of it, may be an infinitesimal fraction of what exists, a single dewdrop in an endless cosmic morning. The universe today bears the imprint of its inflationary birth. The large-scale structure, the cosmic web of galaxy superclusters stretched across billions of light-years, emerged from those primordial quantum fluctuations, amplified by gravity over cosmic time. But there's something odd about this cosmic architecture. The matter we see, the stars, planets, gas clouds, and galaxies, forms only the luminous threads of the cosmic web. The scaffold that shapes this structure, that provides the gravitational backbone around which visible matter congregates, remains unseen. Dark matter, invisible, mysterious, known only through its gravitational effects, outweighs visible matter 5 to 1. We know dark matter exists not because we've detected it directly, but because we see its gravitational fingerprints everywhere, in the rotation of galaxies, in the bending of light around massive clusters, in the formation of cosmic structure itself. Galaxies spin so rapidly that they should fly apart like an untethered merry-go-round, unless they're held together by the gravitational embrace of matter we cannot see. Light from distant quasars bends around invisible mass concentrations, forming cosmic mirages that map the distribution of dark matter across space. The universe simply cannot look the way it does without this unseen component. But what is dark? Matter? We've been asking this question for nearly a century, since Fritz Zwicky first inferred its existence in the 1930s, and still we have no definitive answer. It could be exotic particles that interact via gravity, but not electromagnetic. Forces, particles that pass through ordinary matter like ghosts through walls. It could be primordial black holes formed in the first moments after the Big Bang. It could be a modification to our understanding of gravity itself, though the evidence increasingly disfavors this option. Whatever dark matter is, it's not made of the protons, neutrons, and electrons that constitute everything familiar in our experience. It's something else entirely. A shadow substance that shapes the cosmos while remaining forever beyond our direct perception. This shadow dominance extends beyond dark matter to dark energy, that mysterious repulsive force driving the accelerating expansion of space. Together, dark matter and dark energy constitute about 95% of the total mass energy of the universe. The stars and galaxies that define our cosmic perception, all the matter that has ever been observed by all the telescopes humans have ever built, amount to just 5% of what must exist according to our most successful theories. Imagine walking through a forest where you can only see 5% of the trees, where 95% of the vegetation is invisible to you, detectable only by its effects on soil erosion or wind patterns. That's our predicament when trying to understand the cosmos. We're mapping a landscape that's largely invisible, inferring its contours from sparse, luminous markers. Even that luminous 5%, the normal matter made of atoms, harbors its own mysteries. Most of it isn't in stars or planets, but in diffuse, superheated gas stretched between galaxies in vast cosmic filaments. Of all the atomic matter in the universe, only about 10% has condensed into stars or other compact objects. The rest floats. In the intergalactic medium, a tenuous plasma so diffuse that it would qualify as a hard vacuum by earthly standards, yet concentrated enough to contain most of the universe's atoms. This intergalactic medium isn't just empty space. It's a dynamic, evolving ecosystem shaped by galactic outflows, titanic shock waves, and the whispered influence of dark matter and dark energy. The intergalactic medium also serves as a vast, cosmic archive, preserving the chemical history of the universe. When light from distant quasars passes through this diffuse gas, specific wavelengths are absorbed by different elements, creating a forest of absorption lines in the spectrum, a barcode that encodes the composition and condition of cosmic gas across billions of years. By analyzing these patterns, we can trace how the universe's chemistry evolved, how the first elements forged in the Big Bang, hydrogen and helium, were gradually enriched with heavier elements manufactured in stellar cores and scattered by supernova explosions. The space between galaxies isn't empty. It's a living document of cosmic evolution. Let's turn our attention from the very large to the very small, from cosmic structure to the fundamental building blocks of reality. At the smallest scales, we can probe. Matter consists of quarks and leptons, the elementary particles from which protons, neutrons, and electrons are built. But these particles aren't like tiny billiard balls, discrete objects with definite positions and velocities. They're quantum entities, exhibiting behaviors that defy classical intuition. They can exist in multiple states simultaneously. They can influence each other instantaneously across vast distances. They can tunnel through barriers that should be impenetrable. The deeper we've probed into the subatomic realm, the more we've discovered that reality at its foundation isn't made of things, but of possibilities. Not of objects, but of patterns. Not of separate entities, but of interconnected processes. The very notion of a particle dissolves upon close inspection. Electrons, quarks, and photons aren't discrete points, but excitations in quantum fields that permeate all of space and time. What we perceive as a particle is really a localized vibration in an underlying field, like a wave on the ocean or a ripple on a drum skin. And these quantum fields don't exist in isolation. They interact, combine, and influence each other in ways described by elegant mathematical equations. The electron field interacts with the electromagnetic field, the quark fields interact with the gluon field, and all fields feel the faint tug of the gravitational field. Reality isn't built from fundamental objects, but from fundamental processes, interactions between fields that give rise to what we experience as matter, energy, and force. This field-based understanding of reality resolves many paradoxes of quantum mechanics. The famous wave-particle duality, the observation that quantum entities behave sometimes like particles and sometimes like waves, makes perfect sense if particles are really localized vibrations in underlying fields. The mysterious phenomenon of quantum entanglement, where particles can remain connected regardless of distance, so that measuring one instantly affects the other, becomes less mysterious when we recognize that what appears to be separate particles may be different aspects of a single quantum state extended across space. The quantum world isn't weird because it operates by alien principles. It's weird because we're trying to understand it through classical concepts like particle and location that simply don't apply at that level of reality. But this quantum perspective opens a new mystery: the measurement problem. When we observe a quantum system, its multiple possibilities seem to collapse into a single definite outcome. An electron that existed as a cloud of probability crystallizes into a specific position. A photon that traveled all possible paths between source and detector reveals itself at a specific point. Something happens at the interface between the quantum and classical realms, between the microscopic world of possibilities and the macroscopic world of definite objects. But what? Does consciousness play a role? Does the universe split into parallel branches, each containing a different outcome? Are there hidden variables that determine the result but remain beyond our detection? Despite nearly a century of debate, physicists have reached no consensus on how to interpret what quantum mechanics actually tells us about reality. These aren't mere philosophical quibbles, but questions that strike at the heart of physical reality. And they relate directly to our cosmic questions because the universe itself began in a quantum state, a superposition of possibilities that somehow crystallized into the specific cosmos we observe. The large-scale structure of the universe emerged from quantum fluctuations in the primordial field that drove inflation. The same mysterious boundary between quantum possibilities and classical actualities that puzzles laboratory physicists also shapes our understanding of cosmic origins and evolution. The universe looks the way it does, in part, because of how quantum possibilities became cosmic realities. The marriage of quantum mechanics and cosmology produces offspring that challenge our deepest intuitions about space, time, and existence. Consider the vacuum, what we colloquially call empty space. Quantum field theory reveals that the vacuum isn't empty at all. It's a seething cauldron of virtual particles popping in and out of existence, borrowing energy from the underlying fields in accordance with Heisenberg's uncertainty principle. Even in the deepest void between galaxies, space-time roils with these ephemeral particles, virtual photons, electrons, and their antiparticles flashing briefly into existence before annihilating each other and disappearing back into the quantum foam. The vacuum has energy, pressure, tension, properties we associate with matter, not emptiness. This quantum nature of the vacuum connects directly to dark energy and the accelerating expansion of the universe. The simplest explanation for dark energy is that it's the intrinsic energy of the vacuum itself, the zero-point energy of all quantum fields permeating space. But as mentioned earlier, when we calculate what this energy should be based on quantum theory, we get a value that's wrong by at least 120 orders of magnitude. The greatest disagreement between theory and observation in the history of science. This isn't a minor discrepancy, but a fundamental crisis that suggests we're missing something profound about how quantum fields relate to space-time itself. Our best theories of the very small and the very large, quantum mechanics and general relativity, seem fundamentally incompatible at this critical juncture. This incompatibility isn't just a theoretical inconvenience, it's a window into deeper physics. In extreme environments, inside black holes or during the first moment of the Big Bang, both quantum effects and gravitational effects become equally important, and our separate theories break down. We need a unified theory of quantum gravity to describe such conditions, but constructing such a theory has proven enormously challenging. String theory, loop quantum gravity, causal set theory, various approaches have been proposed, each with its own mathematical elegance and conceptual difficulties. What they share is the recognition that space-time itself may not be fundamental, but emergent, that the smooth, four-dimensional continuum we experience may arise from more fundamental entities, whether vibrating strings in higher dimensions or discrete atoms of space-time itself. These theoretical explorations reveal a universe far stranger than our ancestors could have imagined. A cosmos where space and time themselves may be secondary, derivative phenomena rather than the primary arena in which reality plays out. Space might be a network of quantum entanglements between more fundamental entities. Time might be an emergent property that comes from entropy increase rather than a fundamental dimension. The solid ground of space-time, which seems so evident to our everyday experience, might dissolve upon deeper analysis into something more fluid, more relational, more contingent. This possible ephemeral nature of space-time connects to one of the most profound conceptual revolutions in theoretical physics, the holographic principle. Inspired by the physics of black holes, this principle suggests that all the information contained in a volume of space can be encoded on its boundary, just as a hologram stores three-dimensional information on a two-dimensional surface. For Jantuits, its most radical interpretation, the holographic principle implies that the three-dimensional reality we experience might be a projection from information encoded on a distant two-dimensional surface, like shadows cast on the wall of Plato's cave. The mathematics of string theory has given concrete expression to this principle through the AD-S-CFT correspondence, which establishes an exact equivalence between a gravitational theory in a space of one shape and a quantum field theory without gravity on the boundary of that space. If the holographic principle is correct, and the evidence from theoretical physics strongly suggests it is, then we face another mind-bending possibility. What we experience as depth as the third dimension of space may be a kind of illusion, an emergent property arising from quantum entanglement patterns encoded on a lower dimensional boundary. The seemingly solid volume of space through which you move right now might be more like a holographic projection, not in the science fiction sense of being a computer simulation, but in the deeper sense that volumetric reality emerges from information encoded on a distant surface. The universe looks three-dimensional to you because that's how the information on its boundary manifests when processed by a conscious system embedded within the encoding. This conceptual upheaval extends to our understanding of cosmic origin. The Big Bang might not have been the beginning of everything, but a transition point, a phase change in a much larger, perhaps eternal, reality. Several theoretical frameworks suggest alternatives to the traditional picture of a universe emerging from an initial singularity. Eternal inflation proposes that our observable universe is just one bubble in an endlessly inflating cosmic foam, with new universes constantly budding off from the expanding metaspace. String theory's landscape of possible vacuum states suggests a vast multiverse of domains with different physical laws, connected by quantum tunneling or perhaps existing in parallel. Loop quantum cosmology indicates that the Big Bang might have been a big bounce, with our universe emerging from the collapse of a previous one in an endless cycle of cosmic death and rebirth. These aren't just speculative fantasies, but serious scientific models grounded in our best understanding of fundamental physics. They emerge when we push our theories to their logical conclusions, when we follow the mathematics where it leads without being constrained by our limited intuitions. And they point toward a cosmos far larger, far stranger, and far more diverse than the observable universe that falls within our cosmic horizon. The universe we see, vast though it is, with its hundreds of billions of galaxies spread across billions of light years, may be an infinitesimal fraction of what exists, a tiny bubble in an ocean of reality that exceeds our imagination as thoroughly as a galaxy exceeds an atom. But these grand visions of multiply-connected multiverses raise a troubling question. If the cosmos is so much vaster than what we observe, if multiple universes exist with different properties and different histories, how can we ever hope to test such theories? How do we distinguish profound insight from unfalsifiable speculation? The lines between physics, mathematics, and philosophy blur when we venture into these realms. The challenge facing modern cosmology isn't just explaining what we see, but developing ways to test ideas whose implications exceed our observational reach. One approach is to search for signatures of these broader cosmic structures in the observable universe. If our cosmos collided with another bubble universe in the distant past, it might have left subtle patterns in the cosmic microwave background radiation. If the topology of space is non-trivial, if it connects back on itself in complex ways, it might create distinctive correlations in the distribution of galaxies or the polarization of ancient light. If the constants of nature were different in the distant past, it would affect the relative abundances of elements produced in the early universe or the properties of light from the most distant quasars. Cosmologists have begun searching for these subtle effects, these whispers from beyond our cosmic horizon, using increasingly sophisticated instruments and analysis techniques. Another approach is to seek theoretical coherence and elegance. 2. Look for theories that not only explain what we observe, but do so with mathematical beauty and logical necessity. This was the path that led Einstein to general relativity, not primarily through new observations, but through the pursuit of a more coherent and elegant description of gravity. Similarly, the unification of quantum mechanics and gravity might emerge not from new particle accelerator results, but from identifying the mathematical structure that resolves the deep conceptual tensions between these theories. This approach carries risks. Nature isn't obligated to conform to our aesthetic preferences, But the history of physics reveals a remarkable correlation between mathematical beauty and physical truth. The universe seems to favor elegance in its fundamental laws, even if the consequences of those laws can be messy and complex. The mysteries deepen when we consider the relationship between life and the cosmos, the conditions for complex chemistry, for stable stars that burn for billions of years, for planets with liquid water. All the prerequisites for life as we know it depend exquisitely on the values of fundamental constants like the strength of gravity, the charge of the electron, and the properties of the nuclear forces. Adjust any of these values by a small percentage, and stars burn out too quickly, heavy elements can't form, or atoms themselves become unstable. The universe appears finely tuned for complexity and life, a fact that has inspired varied interpretations, as evidence for purposeful design as a natural consequence of the multiverse, where we inevitably find ourselves in one of the rare universes compatible with our existence, or as an indication that fundamental physics still has deeper unifying principles to discover. This cosmic fine-tuning extends beyond the values of fundamental constants to the initial conditions of the universe itself. The early cosmos had remarkably low entropy. It was highly ordered, with matter distributed very uniformly except for tiny fluctuations. This low initial entropy was necessary for the emergence of cosmic structure, for the gradient that allows stars to shine and life to flourish. But it's also deeply puzzling. Why wasn't the initial state of the universe a chaotic, high-entropy mess? Why did it start in this improbable, highly ordered configuration? The thermodynamic arrow of time, the fact that entropy increases as the universe evolves, traces back to this peculiar cosmic beginning. But what set those initial conditions? The inflationary model offers partial answers, explaining how a small patch of space could have been stretched to cosmic scales. But it pushes the question back. What caused inflation to start from a low-entropy state? These questions about cosmic origins, about why the universe had the properties it did at its earliest moments, stretch the boundaries of what science can address. They verge on metaphysics, on the ancient philosophical question, why is there something rather than nothing? But modern cosmology gives this question new precision and context. We can now frame it in terms of quantum fields, vacuum states, and symmetry breaking. We can ask why the quantum vacuum has the properties it does, why certain symmetries are broken while others remain exact, why the particular pattern of fields and particles that constitute our reality emerged from the plethora of mathematical possibilities. The very fact that we can ask these questions, that the universe has evolved conscious beings capable of contemplating their own origins, may itself be a clue to the nature of reality. Among the many properties of our cosmos, one of the most remarkable is that it has given rise to structures complex enough to model themselves, to develop mathematics and science, to decode the history written in starlight. This emergent complexity, this capacity for self-understanding, isn't separate from the cosmos, but an expression of its inherent potential. The universe hasn't just expanded in space, it has evolved in complexity, from the simplicity of the early plasma to the rich, hierarchical structures of today: galaxies, stars, planets, ecosystems, nervous systems, societies, and cultures. And this evolution of complexity may be as fundamental to cosmic history as the expansion of space itself. But there's a tension between cosmic expansion and emergent complexity. As the universe expands, it cools. As it cools, energy gradients diminish. As gradients diminish, the capacity to perform work and create complexity declines. In the very long term, trillions of years from now, the accelerating expansion driven by dark energy will isolate every galaxy, then every star, then every atom from all others. The cosmos will approach a state of maximum entropy, of heat death, where no further work is possible and complexity cannot be sustained. The window of cosmic history where complex structures can exist appears to be finite. A brief interlude in a vastly longer story, dominated by uniform, featureless expansion. The universe that allows us to ask these questions will, in its far future, make such questioning impossible. This cosmic transience raises profound philosophical issues about meaning and purpose. If complexity is a temporary phenomenon in an ultimately featureless cosmos, does that undermine its significance? Or does the very rarity of this complexity, this brief flaring of consciousness in the cosmic night, make it more precious precisely because it's ephemeral? These aren't questions science alone can answer, but they arise naturally from scientific cosmology. They remind us that the enterprise of understanding the universe isn't just an accumulation of facts, but a quest for meaning, a search for our place in a cosmos that produced us but doesn't revolve around us. The universe we observe, with its galaxies and voids, its stars and planets, its elegant mathematical laws and bewildering quantum behaviors, exists at the intersection of necessity and chance. Some aspects of cosmic structure seem inevitable, the only way things could be given the fundamental laws of physics. Others appear contingent, the result of random quantum fluctuations that happen to produce one outcome rather than another. Disentangling the necessary from the contingent, understanding what had to be versus what just happened to be, remains one of the greatest challenges in cosmology. The universe looks the way it does because of this interplay between mathematical necessity and historical accident, between the immutable laws of physics and the particular path cosmic evolution happened to take. But this distinction between law and accident, between necessity and contingency, may itself be an artifact of our limited perspective. From a multiverse perspective, every physically possible universe exists somewhere in the greater cosmic structure. What appears to us as random, the specific pattern of temperature fluctuations in the cosmic microwave background, the particular arrangement of galaxies in our cosmic neighborhood, may be determinate in the sense that it could not have been otherwise in our universe, even if other patterns occurred in other domains of the multiverse. The apparent contingency in our cosmic environment might be an illusion created by our limited ability to access the larger structure of reality, just as the apparent randomness of a page of digits from pi would disappear if we could see the entire transcendental number they're part of. This perspective suggests a profound possibility that the distinction between laws of physics and initial conditions, between how the universe evolves and the state from which it started, might dissolve at the deepest level of reality. What we perceive as fixed laws operating on contingent states might be different aspects of a single mathematical structure, a unified description where what had to be and what happened to be are indistinguishable. The universe might be a self-contained, mathematical object with no external parameters that could have been different, no knobs that could have been turned. The question, why these laws and not others, might have the same answer as the question, why these initial conditions and not others? Namely, that in the complete description of reality, no other possibilities exist. Or perhaps the opposite is true. Perhaps every mathematical possibility is physically real somewhere in the greater multiverse, and the particular combination of laws and conditions we observe is just one point in an infinite landscape of possibilities. In this view, our universe isn't special in its laws or its history. It's special only in that it allows for observers like us to evolve and ask these questions. The anthropic principle reminds us that any universe we observe must be compatible with our existence, which places significant constraints on the properties we'll measure. We shouldn't be surprised to find ourselves in a universe that allows for complexity and life, even if such universes are rare in the greater cosmic ensemble, because we couldn't exist in the vast majority of universes that don't support complexity. These anthropic considerations can explain some aspects of cosmic fine-tuning, but they leave other questions unanswered. Why is our universe so much more hospitable to life than it needed to be? The cosmological constant, dark energy, is indeed within the narrow range that allows galaxies to form, but it's much closer to zero than that range requires. The universe contains many more galaxies, stars, and planets than would be needed for life to evolve somewhere. If our existence selects which universe we find ourselves in, we should expect to find ourselves in a universe that just barely allows for our evolution, not one that massively overshoots the minimum requirements. The fact that our cosmos seems extravagantly hospitable to complexity, rather than minimally so, suggests that anthropic selection alone cannot explain all aspects of cosmic fine-tuning. The challenge of modern cosmology isn't just describing what the universe contains or how it evolves, but understanding why it has the particular properties it does, rather than others that seem equally plausible mathematically. This question leads to the frontiers of fundamental physics, to the search for a theory of everything that would unify all forces and particles in a single coherent framework. String theory, loop quantum gravity, causal set theory. These approaches seek not just to reconcile quantum mechanics with gravity, but to derive the specific pattern of particles and forces we observe from deeper principles. The hope is that the particular collection of particles discovered by experimental physics, the 6 quarks, 6 leptons, 4 force carriers, and the Higgs boson, isn't arbitrary, but follows necessarily from a more fundamental structure, just as the periodic table of elements follows from the principles of quantum mechanics applied to electrons and nuclei. But even a successful theory of everything would leave certain questions open. Why does the universe follow this particular mathematics, rather than some other? Why does mathematics describe physical reality at all? The unreasonable effectiveness of mathematics in describing the natural world, as physicist Eugene Wigner called it, is itself a profound mystery. Mathematical structures invented for purely abstract purposes have repeatedly turned out to describe physical phenomena with uncanny precision. Complex numbers, tensor calculus, non-Euclidean geometry, group theory, all developed as abstract mathematics before finding perfect application in physical theories. This suggests a deep connection between mathematical truth and physical reality, a connection that some philosophers and physicists have interpreted as identity. Perhaps physical reality is mathematical structure, not merely described by it. This brings us back to the fundamental question: why does the universe look the way it does? Perhaps because it couldn't have been otherwise. Because the particular pattern of fields, particles, and forces we observe is the only logically consistent solution to the equations of some deeper theory we haven't yet fully formulated. Perhaps because it's one manifestation among countless others in a vast multiverse, distinguished only by the fact that it allows creatures like us to evolve and observe it. Perhaps because reality at its foundation isn't what we think it is, not a collection of things evolving in space and time, but a mathematical structure outside space and time, with space, time, and matter emerging as patterns within this deeper reality. Or perhaps the question itself needs reformulation. When we ask why the universe looks the way it does, we're assuming it looks some specific way, that it has definite properties independent of observation. But quantum mechanics suggests a different perspective, that unobserved reality exists as potentialities rather than actualities, that the specific properties we measure aren't inherent in the system before measurement, but emerge through the interaction between observer and observed. In this view, The question isn't why the universe has the properties we observe, but why our observations yield the particular pattern they do. A pattern shaped not just by what exists independently of us, but by the specific ways we interact with and measure reality. This observer dependence of reality becomes particularly significant in cosmology, where the thing being observed, the universe, includes the observer. We aren't external scientists examining a separate system. We're patterns within the system studying the system itself. Our theories, our observations, our very questions are phenomena within the cosmos we're trying to understand. This creates a kind of self-reference that may limit what we can know about the whole. Just as Gödel's incompleteness theorems show that no formal mathematical system can prove all truths about itself, no theory formulated within the universe may be able to explain all aspects of the universe. There might be fundamental limitations to cosmic self-understanding, not because of practical constraints on our knowledge, but because of logical constraints on what can be known by a system about itself. If the universe looks the way it does, partly because of how we look at it, then the search for cosmic understanding becomes a more subtle enterprise than simply cataloging what exists out there. It becomes an exploration of the relationship between observer and observed, between consciousness and the reality it perceives. This doesn't mean the universe is a subjective mental construct. The cosmos existed long before humans evolved to observe it. But it does suggest that the specific way reality manifests to us is shaped by the particular type of consciousness doing the observing. A different type of conscious system, with different sensory apparatus and different neural architecture, might perceive a differently structured reality, even if the underlying mathematical patterns remain the same. This brings us to one of the deepest mysteries of all, the relationship between consciousness and the physical world. Consciousness isn't just another phenomenon in the universe. It's the means by which the universe is perceived and understood. Without it, there would be no observation, no measurement, no science, no questions about why the cosmos looks the way it does. Yet consciousness itself remains poorly understood from a physical perspective. How does subjective experience emerge from neural activity? How does awareness arise from arrangements of particles that individually show no signs of mind or intentionality? Some philosophers have suggested that consciousness might be fundamental rather than emergent, not something that appears when matter is arranged in certain complex ways, but an intrinsic aspect of reality that manifests to different degrees, in different systems. In this view, the relationship between mind and matter isn't one of emergence, but of complementarity. They're different aspects of the same underlying reality, like two sides of a coin. If consciousness is fundamental rather than emergent, the question of why the universe looks the way it does takes on new dimensions. The cosmos, as we perceive it, might be partly shaped by the intrinsic connection between consciousness and the physical world, by how mind and matter relate at the most fundamental level. The comprehensibility of the universe, the fact that human minds can understand its structure through mathematics and physics, might not be a happy accident, but a consequence of a deeper unity between consciousness and the reality it perceives. The universe might be intelligible to consciousness because consciousness and physical reality are woven from the same fundamental fabric. The most profound mysteries aren't those we know we don't understand. They're the ones hidden within what we think we already comprehend. Take gravity, a force so familiar that we rarely question it. You drop an object, it falls. Planets orbit stars. Galaxies hold together. Simple, intuitive, obvious. Yet within this everyday phenomenon lies a conceptual abyss that has swallowed some of the greatest minds in physics. Einstein showed us that gravity isn't a force at all, but the curvature of space-time itself. Matter telling space how to bend, space telling matter how to move. but push this elegant picture to its limits and reality fractures. At the center of a black hole, in the first moment of the Big Bang, Einstein's equations break down completely. The mathematics screams with infinities, space-time itself shatters, and our most successful theory of gravity simply stops working. Now, imagine reality as a film reel. In this analogy, time isn't flowing. It's already fully imprinted on the celluloid. Every frame, every moment already exists. Past, present, future. All there, eternally encoded on the cosmic film. We experience just one frame at a time, creating the illusion of flowing time. But the entire reel exists simultaneously. This is the block universe perspective, suggested by Einstein's relativity, where time is simply another dimension. No, different in kind from the three dimensions of space. There's no universal now sweeping forward, no objective present moment that all observers would agree upon. Different observers moving at different velocities will disagree about which events are simultaneous, which are past and which are future. The clean division we perceive between past and future is an artifact of our limited perspective, not a fundamental aspect of reality. This static view of time creates a paradox at the heart of physics. If the entire cosmic film reel already exists, if the future is as real and determined as the past, then what happens to free will, to possibility, to the open future we intuitively experience? And if time doesn't flow at the fundamental level, why do we experience it flowing? Why does entropy increase in one direction of time, but not the other? Why can we remember the past, but not the future? Relativity gives us the stage, the four-dimensional arena of space-time, but it doesn't explain why events unfold in the particular way they do upon that stage. Why the cosmic story has the plot it does, rather than countless other possible plots. These questions lead us to quantum mechanics, where time plays by different rules. In the quantum realm, the future isn't determined but probabilistic. Particles exist not in definite states, but as superpositions of possibilities, as clouds of potential that collapse into definite reality only when measured. The quantum universe isn't like a film with a predetermined plot, but more like an improvisational play where each scene's outcome remains uncertain until performed, where multiple storylines exist in superposition until one is selected through the mysterious process of measurement. This creates a fundamental tension in modern physics. Relativity suggests a block universe where time is an illusion and the future is as fixed as the past. Quantum mechanics suggests an open universe where the future exists only as a cloud of probabilities until observed. Both theories have been confirmed by countless experiments. Both appear to be true descriptions of reality, yet they paint incompatible pictures of how time works at the most fundamental level. This isn't merely a technical disagreement, but a profound conceptual rift about the nature of reality itself. One proposed solution to this paradox comes from Hugh Everett's many worlds interpretation of quantum mechanics. In this view, every possible outcome of every quantum event actually occurs, not just as a possibility, but as a reality, in its own branch of an endlessly splitting multiverse. When you measure the spin of an electron and find it pointing up, in another branch of reality, an alternate version of you measures the same electron and finds it pointing down. Both outcomes are equally real, just in different branches of a vast cosmic tree of possibilities. The many worlds interpretation resolves the tension between relativity and quantum mechanics by suggesting that the block universe isn't a single four-dimensional structure, but a five-dimensional one that includes all possible histories and futures. The cosmic film reel isn't just one movie, but every possible variant of that movie, all existing simultaneously in a grand superposition of realities. From this perspective, what we perceive as the collapse of quantum possibilities into a single outcome isn't a collapse at all, but a splitting of our conscious experience into different branches of reality, each following one of the possible outcomes. This isn't science fiction. It's a serious interpretation of quantum mechanics that emerges naturally from taking the mathematical formalism at face value. If quantum states evolve according to Schrödinger's equation, and if that equation is a complete description of reality, then there's no mechanism for the wave function to collapse into a single outcome. Instead, all possibilities described by the wave function must be equally real, just experienced in different branches of an ever-expanding tree of realities. The implications are staggering. Every quantum choice point in the history of the universe, and there have been countless such points since the Big Bang, creates a new branching of reality. The multiverse isn't just vast, it's unimaginably, incomprehensibly vast, containing every possible variation of cosmic history consistent with the laws of physics. In some branches, you made different life choices. In others, Earth never formed. In still others, the constants of nature themselves may differ slightly, creating altogether different kinds of physics and chemistry. But this raises a troubling question. If every possible outcome occurs in some branch of reality, what meaning does probability have? Why do quantum measurements show some outcomes being more likely than others? The many worlds answer is that probability reflects the measure or weight of different branches. Essentially, what fraction of the total multiverse contains that particular outcome. When quantum mechanics says an electron has a 70% chance of being measured with spin-up, it means that 70% of the post-measurement branches contain an electron with spin-up, while 30% contain an electron with spin-down. Yet, this neat solution creates new puzzles. How do we define this measure or weight of branches? What physical meaning does it have? And how can we test the existence of these other branches empirically, given that they're causally disconnected from our own? The many worlds interpretation offers a mathematically elegant picture of reality, but at the cost of positing an infinity of unobservable parallel universes, a high metaphysical price tag that gives many physicists pause. An alternative approach seeks to resolve the tension between quantum mechanics and relativity, not by embracing parallel universes, but by modifying our understanding of time itself. The relational interpretation of quantum mechanics, championed by physicist Carlo Rovelli, suggests that physical properties like position, momentum, or spin don't exist in absolute terms, but only relative to other physical systems. An electron doesn't have a specific position in absolute space. It has a position relative to the laboratory apparatus measuring it, another position relative to a passing neutrino, and so on. This relational perspective extends to time as well. There's no absolute universal time flowing at the same rate for all systems, but rather a web of relations between events. Different systems can evolve along different temporal sequences, and what counts as now for one system may be entirely different from what counts as now for another. This doesn't just mean that clocks tick at different rates for observers moving at different velocities, as special relativity tells us. It means that the very distinction between past, present, and future might be relative rather than absolute, a perspective that aligns with general relativity's unification of space and time into a single manifold. From this viewpoint, quantum's mechanics doesn't conflict with relativity's block universe. It complements it by revealing the relational nature of physical properties within that block. The wave function doesn't collapse from multiple possibilities to a single reality. Rather, correlations form between the system being measured and the measuring apparatus, creating what appears as a definite outcome relative to that specific measurement context. Different measurement contexts can reveal different, even contradictory properties of the same system. Not because reality changes, but because the relationships being probed are different. This relational approach offers a path to quantum gravity, the long-sought unification of quantum mechanics and general relativity, through loop quantum gravity, a theory that describes space-time itself as a network of quantum relationships, rather than a smooth, continuous fabric. In this picture, space isn't an empty stage upon which matter performs. It's a dynamic web of relationships between quantum events. At the Planck scale, the incredibly tiny scale where quantum gravity effects become significant, space-time itself becomes granular, quantized into elementary units often pictured as atoms of space. Loop quantum gravity makes a radical prediction. The breakdown of space-time in the very early universe or at the center of black holes isn't a failure of our theories, but a feature of reality itself. Space and time actually dissolve at these extremes, replaced by a more fundamental quantum network of relationships that doesn't include familiar notions of distance or duration. The Big Bang wasn't the beginning of everything, but a phase transition, a moment when this quantum network condensed into the semi-classical space-time we now inhabit, like liquid water crystallizing into ice, but with dimensions of space and time congealing from a more primal state where such dimensions weren't well defined. This picture transforms our understanding of cosmic origins. The question, what happened before the Big Bang, becomes meaningless, not because time began at the Big Bang, but because before implies a temporal relationship that doesn't exist in the quantum gravity regime. It's like asking, what's north of the North Pole? The question assumes a spatial relationship that breaks down at that particular point. Similarly, temporal relationships, as we understand them, simply don't apply beyond the Big Bang boundary. There wasn't a before in any meaningful sense. An alternative approach to quantum gravity comes from string theory, which proposes that the fundamental constituents of reality aren't point-like particles, but tiny vibrating strings of energy. Different vibration patterns of these strings manifest as different particles: electrons, quarks, photons, gravitons, just as different vibration patterns of a violin string produce different musical notes. This elegant unification of all particles and forces, including gravity, requires a startling mathematical feature. The strings vibrate not in our familiar 3 dimensions of space, but in 9 or 10 or even 26, depending on the specific version of the theory. Where are these extra dimensions? Why don't we perceive them? String theory suggests they're tightly curled up at every point in our familiar space-time, too small to be directly observed, but leaving their fingerprints on the physics we measure. The specific way these extra dimensions are compactified, folded, and twisted into tiny, complex geometries determines the particles and forces we observe in our 4-dimensional world. It's as if the universe is a vast symphony played on interdimensional strings, with the specific geometric configuration of hidden dimensions determining the cosmic music we experience as reality. String theory offers multiple solutions to the paradoxes of quantum gravity. The infinities that plague attempts to quantize Einstein's gravity disappear when gravity emerges from the vibrations of extended strings rather than point particles. The singularities at the centers of black holes and at the Big Bang are smoothed out, replaced by more complex but mathematically well-behaved string configurations. And the holographic principle, the idea that all the information contained in a volume of space can be encoded on its boundary, emerges naturally from string theory mathematics, suggesting a profound connection between gravity in our universe and quantum field theories without gravity in a space with one fewer dimension. But string theory faces a significant challenge. The mathematics allows for an enormous number of possible configurations of these extra dimensions, perhaps $500 or more. each creating a different low-energy universe with different particles, forces, and constants. This vast landscape of possible universes raises the specter of the anthropic principle. Perhaps our universe isn't the way it is because of some deep mathematical necessity, but simply because its particular configuration allows for the evolution of conscious observers who can ask why the universe is the way it is. In the string theory landscape, all possible universe configurations exist somewhere in the multiverse, and we inevitably find ourselves in one of the rare configurations compatible with our existence. This anthropic reasoning makes many physicists deeply uncomfortable. Science has always sought unique explanations, mathematical necessities that leave no room for alternatives. The idea that the specific pattern of particles and forces we observe is just one possibility among countless others, selected not by mathematical elegance, but by the brute fact that we couldn't exist to observe the alternatives, feels to many like giving up on explanation altogether. If any configuration consistent with basic mathematical constraints can exist somewhere in the multiverse, then why does our particular corner of reality have the specific properties it does? The string theory landscape threatens to replace explanation with mere description, necessity with contingency. Yet the anthropic principle gains force when we consider just how fine-tuned our universe appears to be for complexity and life. The strength of gravity, the mass of the electron, the binding energy of atomic nuclei, the cosmological constant, all are calibrated with incredible precision to values that allow for atoms, stars, planets, and complex chemistry. Adjust any of these values by a small percentage, and the universe becomes inhospitable to complexity. If there's only one possible configuration for the universe, why should it happen to have exactly the properties needed for life? If there are many possible configurations, realized in different domains of a vast multiverse, then it's no surprise that we find ourselves in one of the rare life-supporting domains, even if such domains are an infinitesimal fraction of the whole. This tension between unique explanation and anthropic selection defines much of contemporary fundamental physics. Are the specific properties of our universe necessary, the only possible solution to some deeper mathematical constraint? Or are they contingent, one possibility among countless others, distinguished only by the fact that they allow us to exist? And ask these questions? The answer remains unclear, but the question itself reveals how deeply the observer, consciousness itself, has become entangled with cosmological explanation. We can no longer neatly separate the universe being observed from the fact of observation, the cosmic properties from the presence of beings capable of measuring those properties. This observer centrality appears most starkly in interpretations of quantum mechanics that assign a special role to consciousness. The original Copenhagen interpretation, as articulated by Niels Bohr and Werner Heisenberg, drew a sharp distinction between the quantum world of possibilities and the classical world of definite measurements, with conscious observation mediating the transition between them. Later interpretations, like that of Eugene Wigner, went further, suggesting that consciousness itself might be the missing ingredient that transforms quantum superpositions into definite outcomes. In this view, the universe exists in a state of quantum potentiality until a conscious mind interacts with it, collapsing potential into actuality through the act of observation. Most contemporary physicists reject this consciousness-centric view, pointing to decoherence, the process by which quantum systems interact with their environment, causing quantum behavior to fade into classical behavior without requiring conscious observers. A quantum system doesn't need to be observed by a conscious mind to behave classically. It just needs to become entangled with a sufficiently complex environment, which causes its quantum wave function to become effectively irreversible. The environment itself acts as a kind of observer, continuously measuring the system and forcing it to behave in ways indistinguishable from classical physics. But decoherence doesn't fully resolve the measurement problem. It explains why quantum systems behave classically when interacting with complex environments, but it doesn't explain why one particular classical outcome occurs rather than another. The quantum wave function still contains multiple possibilities. Decoherence just makes these possibilities unable to interfere with each other. The question remains, why does reality choose one specific decoherent branch rather than another? And this question leads us back to interpretations like many worlds, all branches are equally real, or modifications to quantum mechanics itself. One such modification, proposed by physicist Roger Penrose, suggests that gravity plays a crucial role in wave function collapse. In Penrose's theory, quantum superpositions of significantly different mass distributions create corresponding superpositions of spacetime geometries. These geometric superpositions are unstable and spontaneously collapse to a single definite geometry, taking the quantum state with them. The more mass involved in the superposition, the faster this gravitational collapse occurs, which is why quantum effects are readily observable for tiny particles but not for macroscopic objects like cats or humans. Penrose's theory makes testable predictions, including a specific threshold at which quantum superpositions should collapse due to gravitational effects. It also suggests a potential connection between quantum gravity and consciousness. In collaboration with anesthesiologist Stuart Hameroff, Penrose has proposed that quantum coherence in brain microtubules might play a role in consciousness, with gravitational wave function collapse serving as the physical correlate of conscious experience. This speculative but intriguing idea suggests that consciousness might emerge from processes at the interface between quantum and classical physics, between the microscopic realm of possibilities and the macroscopic realm of definite outcomes. Whether or not this specific theory proves correct, it highlights a profound insight. The boundary between quantum and classical behavior, between the probabilistic micro-world and the determinate macro-world, may be central not just to understanding fundamental physics, but to understanding consciousness itself. Our subjective experience has features that mirror this quantum classical boundary. We experience definite perceptions and make definite choices, yet these emerge from neural processes that involve enormous numbers of quantum particles. The collapse from multiple neural possibilities to a single conscious experience may be connected to the physical collapse from quantum possibilities to classical outcomes. This potential connection between quantum physics and consciousness gets even more intriguing when we consider time. Quantum mechanics treats time differently from relativity. In relativity, time is just another dimension in the block universe, with all moments existing equally. In standard quantum mechanics, time remains a classical parameter that flows uniformly, not subject to quantum uncertainty. But in quantum gravity, time itself becomes quantized, subject to the same indeterminacy as other physical quantities. At the Planck scale, 10 to 43 seconds after the Big Bang, the distinction between past and future may dissolve into a quantum foam of space-time, where causal connections become probabilistic rather than definite. Some approaches to quantum gravity, like causal set theory, propose that causality itself is the fundamental construct from which both space and time emerge. Rather than space-time being a continuous fabric, it consists of discrete events connected by causal relationships. This happened because of that, which happened because of something else. The familiar dimensions of space and time emerge from this causal network when viewed at scales much larger than the Planck length. In this picture, the fundamental level of reality isn't space or time or matter, but pure information about what influences what. A cosmic web of causes and effects from which all physical properties emerge. This informational perspective on reality connects to another revolutionary idea, the holographic principle. Inspired by the physics of black holes, the holographic principle suggests that all the information contained in a volume of space can be encoded on its boundary surface. Just as a two-dimensional hologram can recreate a three-dimensional image, the physics within a region of space might be entirely encoded in the physics at the boundary of that region. This isn't just a useful mathematical trick, but a profound statement about the nature of space itself. It suggests that what we experience as three-dimensional volume might be a projection from a more fundamental two-dimensional reality. The holographic principle found concrete expression in string theory through the ADSI-CFT correspondence discovered by Juan Maldacena in 1997. This mathematical relationship establishes a precise equivalence between a gravitational theory in a space with negative curvature, anti-de Sitter or ADS space, and a quantum field theory without gravity. On the boundary of that space, a conformal field theory or CFT. The two descriptions, gravitational and non-gravitational, capture exactly the same physics, just expressed in radically different languages. This duality between gravity in the bulk and quantum fields on the boundary suggests that spacetime itself, the stage upon which the cosmic drama unfolds, might be emergent rather than fundamental. What we experience as spatial depth, as the third dimension extending from any surface, might be encoded in the quantum entanglement patterns. On that surface, space itself might be a manifestation of quantum entanglement, a way of visualizing the connections between quantum systems rather than an independently existing backdrop. If space is emergent from entanglement, then the expansion of the universe takes on new meaning. When we say space is expanding, we might really be saying that the pattern of quantum entanglements is evolving in a specific way. The accelerating cosmic expansion driven by dark energy might reflect a fundamental tendency in the underlying quantum information, rather than a mysterious anti-gravitational force pushing space apart. And the Big Bang itself might represent not a beginning of everything, but a reorganization of quantum information, a change in how the fundamental reality is encoded rather than a moment of creation, ex nihilo. This information-theoretic perspective transforms our understanding of black holes, those cosmic objects so dense that nothing, not even light, can escape their gravitational pull. According to Einstein's general relativity, the matter that forms a black hole collapses to a singularity, a point of infinite density where space and time themselves break down. But quantum mechanics doesn't allow for such infinities. The holographic principle suggests a resolution. All the information about what fell into the black hole is encoded on its event horizon, the boundary beyond which nothing can escape. The interior spacetime, including the singularity, might be a redundant description of that same information, not an independent physical reality. This reframing resolves the infamous black hole information paradox, which asks what happens to information that falls into a black hole when the black hole eventually evaporates through Hawking radiation. If information is truly lost, it violates a fundamental principle of quantum mechanics, that physical processes should be reversible in principle, even if they're practically irreversible due to entropy increase. The holographic perspective suggests that the information isn't lost, but encoded on the horizon in a highly scrambled form, eventually released through subtle correlations in the Hawking radiation as the black hole evaporates. But this solution creates new puzzles. If all the information about what fell into a black hole is encoded on its horizon, what happens to someone who crosses that horizon? According to general relativity, they experience nothing special at the moment of crossing. It's just another region of spacetime, albeit one from which escape is impossible. But if the holographic principle is correct, Crossing the horizon might involve a kind of quantum copying of information, with one version encoded on the horizon and another experienced by the falling observer. This creates the possibility of black hole firewalls, regions of intense energy at the horizon that would incinerate anything falling in direct contradiction to what general relativity predicts. This tension between the smooth spacetime of general relativity and the information requirements of quantum mechanics represents one of the deepest paradoxes in contemporary physics. At its heart is a conflict between locality, the principle that physical influences can't travel faster than light, and unitarity, the principle that quantum information can't be destroyed. Black holes force these principles into direct conflict, suggesting that at least one of them must be modified in a theory of quantum gravity. Similar paradoxes emerge in cosmology. The early universe was remarkably uniform, the same temperature in all directions to 1 part in 100,000, as revealed by the cosmic microwave background radiation. But regions on opposite sides of the observable universe haven't had time to communicate with each other since the Big Bang. They're outside each other's causal horizons. How did they reach the same temperature without any causal interaction? The standard explanation invokes cosmic inflation, an exponentially rapid expansion in the first fraction of a second that stretched previously connected regions far apart. But inflation itself requires precise initial conditions, raising questions about how those conditions arose. The holographic principle offers an alternative perspective. If our three-dimensional cosmos is encoded on a two-dimensional boundary, then regions that appear causally disconnected in the bulk spacetime might actually be connected through the boundary encoding. Information doesn't need to travel through the bulk, respecting the light speed limit of ordinary space, but can be connected through the boundary description, where distance relationships are entirely different. The remarkable uniformity of the cosmic microwave background might reflect constraints in the boundary theory rather than causal processes in the expanding space. This holographic reframing of cosmology connects to one of the most ambitious attempts to unify physics, the it-from-bit hypothesis proposed by physicist John Wheeler, which suggests that information is more fundamental than physical objects, that physical reality emerges from information, not the other way around. In this view, the universe isn't made of things but of answers to yes or no questions, of bits of information from which physical properties emerge when observed. Matter, energy, space, and time aren't fundamental but derivative, patterns that arise when information is processed by observing systems. Wheeler's vision aligns with recent developments in quantum information theory, which increasingly views quantum mechanics not as a theory of particles or waves, but as a theory of information, specifically information that can exist in superposition, that can be entangled across space, and that obeys constraints unlike those of classical information. Theory: quantum bits, or qubits, can exist in multiple states simultaneously, allowing quantum computers to perform certain calculations exponentially faster than classical computers. This suggests that reality at its foundation might be informational, rather than material, a cosmic computation whose output is the physical world we experience. But this informational perspective raises profound questions about the nature of reality. If the physical world emerges from information, what processes that information? If reality is computational at its core, what is the hardware on which the cosmic software runs? And most provocatively, could consciousness itself be connected to this fundamental informational reality, not as an epiphenomenon of material processes, but as an intrinsic aspect of how information manifests as physical reality? These questions lead us to even more speculative terrain. The possibility that consciousness and physical reality are complementary aspects of the same underlying reality, like two sides of a Mobius strip that appear distinct but are actually continuous. Some interpretations of quantum mechanics, like that proposed by physicist Henry Stapp, suggest that the physical world exists as a field of quantum possibilities until conscious observation selects certain possibilities from the field, actualizing them as physical reality. In this view, consciousness isn't produced by the brain. Rather, brain states correlate with conscious experiences because both emerge from a deeper, pre-physical level of reality that has both mental and physical aspects. Such ideas verge on philosophical idealism, the view that mind or consciousness is more fundamental than matter. But they can also be seen as extensions of information-theoretic approaches to physics, where information isn't just data about reality, but constitutive of reality itself. Consciousness might be what information feels like from the inside, while physical reality might be how information is structured when viewed from the outside. The two might be different aspects of the same underlying phenomenon, like how electricity and magnetism were revealed to be aspects of the same electromagnetic field by Maxwell's equations. This doesn't mean that consciousness creates reality, in a simplistic sense, that nothing exists until observed by a human mind. Rather, it suggests that the distinction between observer and observed, between mind and matter, might dissolve at the most fundamental level of reality. The universe may be participatory, as Wheeler suggested, with observation playing a constitutive role in determining what properties become definite. But this participation occurs at all levels of complexity, not just in conscious human observation. A photon observing an electron through electromagnetic interaction participates in actualizing certain properties of that electron, just as a human observing a quantum system through laboratory equipment participates in actualizing certain experimental outcomes. The key insight here isn't that human consciousness is somehow special or central to reality, but that observation or measurement is a fundamental aspect of how reality manifests. And human consciousness represents a particularly complex and self-reflective form of this universal process. We're not outside nature, looking in. We're expressions of nature, looking at itself. And this self-reference creates peculiar loops in our understanding, places where the observer becomes entangled with the observed in ways that challenge our conceptual frameworks. Such entanglement appears most dramatically in cosmology, where we attempt to understand the universe as a whole, including ourselves as observers within it. The anthropic principle reminds us that any universe we observe must have properties compatible with the evolution of observers. Otherwise, there would be no one to observe it. This creates a selection effect that constrains what we can observe, independent of what might exist beyond our observational limits. The universe looks the way it does, in part, because it has evolved observers who can see it this way. And those observers, in turn, have evolved because the universe has properties that allow for complexity and consciousness. This anthropic reasoning extends beyond the evolution of life to the fundamental constants of physics themselves. The strength of gravity, the mass of the electron, the binding energy of atomic nuclei all must fall within narrow ranges to allow for stars that burn steadily for billions of years, for planets that can retain atmospheres, for chemistry complex enough to support life. If these constants were even slightly different, we wouldn't be here to notice. And if a vast multiverse exists with different constants in different domains, we inevitably find ourselves in one of the rare domains where these constants enable complexity and consciousness. But anthropic selection doesn't explain why a universe or multiverse exists at all, nor why it has the specific mathematical structure it does. The fact that we can describe the cosmos using elegant mathematical equations, that abstract structures conceived by human minds correspond precisely to the behavior of physical reality, remains a profound mystery. The unreasonable effectiveness of mathematics in describing the natural world, as physicist Eugene Wigner called it, hints at a deep connection between mind and reality, between the structures discoverable by consciousness and the structures that constitute the physical world. This connection becomes even more striking when we consider the role of symmetry in fundamental physics. The standard model of particle physics, our most successful theory of the subatomic world, is constructed almost entirely from symmetry principles. The specific pattern of quarks, leptons, and force carriers emerges from mathematical requirements of symmetry and symmetry breaking. The Higgs field, whose discovery completed the standard model, represents a spontaneous breaking of electroweak symmetry that gives mass to elementary particles. Without this symmetry breaking, all particles would be massless, atoms couldn't form, and complexity would be impossible. But why these particular symmetries and not others? Why SU, 3-SU, 2-XU, ED1 for the standard model gauge group rather than some other mathematical structure? String theory suggests that our low-energy physics emerges from the symmetries of strings vibrating in higher dimensions, but this pushes the question back. Why strings? Why those dimensions? Why those vibration patterns? At each level, we find mathematical structures of remarkable elegance, but the selection of one specific structure from the space of mathematical possibilities remains mysterious. This mystery deepens when we consider the role of symmetry in aesthetics and cognition. The human mind finds symmetrical patterns pleasing, recognizes them more easily than asymmetrical ones, and uses symmetry as a guiding principle in art, music, and mathematics. Is this merely a coincidence, an evolutionary adaptation that happens to align with the symmetries found in fundamental physics? Or does it reflect a deeper connection between consciousness and the mathematical structures that underlie physical reality? The Platonic tradition in philosophy suggests that mathematical structures exist independently of the physical world and of human minds, that we discover rather than invent mathematics. In this view, the correspondence between mathematical elegance and physical reality isn't coincidental, but reflects the fact that both physical reality and conscious understanding tap into the same realm of abstract forms. The universe is mathematically structured not because mathematics is a human invention that happens to work well for describing reality, but because reality itself is mathematical at its foundation. This Platonic perspective aligns with the mathematical universe hypothesis proposed by physicist Max Tegmark, which suggests that physical reality is isomorphic to a mathematical structure, not merely described by mathematics, but actually identical with it. In this view, all mathematically consistent structures exist as physical realities somewhere in the multiverse. What we experience as particles, forces, space, and time are actually relations within a particular mathematical structure, one that happens to allow for complex subsystems capable of internal modeling, what we call consciousness. Such mathematical Platonism offers a potential explanation for why the universe is comprehensible to human minds. We can understand reality because both our minds and the physical world are expressions of the same underlying mathematical structures. The intelligibility of the cosmos isn't a happy accident, but a consequence of the fact that consciousness and physical reality share a common mathematical foundation. We can decipher the cosmic code because our minds are themselves expressions of that code, patterns within the same mathematical tapestry. But this raises new questions about consciousness itself. If physical reality is mathematical structure, what aspects of that structure give rise to subjective experience? How does the felt quality of consciousness, what philosophers call qualia, emerge from abstract relations between mathematical entities? The hard problem of consciousness, as philosopher David Chalmers has called it, asks why physical processes, which could in principle be fully described by mathematical physics, are accompanied by subjective experience at all. Why isn't the Universe just a collection of physical processes, operating according to mathematical laws, without any inner life or awareness. One approach to this hard problem comes from integrated information theory, developed by neuroscientist Giulio Tononi, which proposes that consciousness arises from complex systems that integrate information in specific ways. In this view, consciousness isn't an all-or-nothing property, but a continuum, with different systems possessing different degrees of consciousness depending on their capacity for information integration. The human brain, with its intricate network of billions of neurons forming a unified field of integrated information, represents a high degree of consciousness. But simpler systems, animals, single cells, perhaps even elementary particles, might possess consciousness of a much simpler kind, corresponding to their more limited capacity to integrate information. This panpsychist view, where consciousness is a fundamental feature of reality present to some degree in all systems, has been championed by philosophers like Galen Strawson and David Chalmers as a solution to the hard problem. Rather than trying to derive consciousness from unconscious physical processes, a seemingly impossible task, panpsychism starts with the assumption that consciousness is basic, not derivative. The complex consciousness we experience emerges from simpler forms of consciousness inherent in the physical processes that constitute our brains, just as complex physical systems emerge from simpler physical components. Panpsychism doesn't mean that elementary particles have thoughts or feelings. In the human sense, any more than a hydrogen atom has the properties of wetness found in water molecules. But it suggests that the physical and the phenomenal are two aspects of the same reality. That what physics describes in terms of structure and relation has an intrinsic nature that, when sufficiently complex and integrated, manifests as consciousness. The hard problem of consciousness becomes less mysterious if we see consciousness not as something that needs to be derived from entirely non-conscious matter, but as the intrinsic nature of what physics describes extrinsically. This dual aspect, theory of reality, connects to an ancient philosophical tradition that sees mind and matter as complementary expressions of a deeper unity. In Western philosophy, this view appears in Spinoza's concept of a single substance with both mental and physical attributes. In Eastern traditions, it emerges in the Vedantic concept of Brahman, the underlying reality that manifests both as objective world and as subjective awareness. These philosophical approaches weren't developed with modern physics in mind, but they offer conceptual frameworks that might help integrate consciousness into our scientific understanding of reality. The integration of consciousness into physics doesn't mean abandoning scientific rigor for mysticism. Rather, it suggests expanding our conception of what counts as physical, recognizing that our current physical theories describe the structural, relational aspects of reality, but may remain silent on its intrinsic nature. Consciousness might be what reality is like from the inside, while physics describes what reality is like from the outside. The two descriptions are complementary, not contradictory, offering different perspectives on the same underlying reality. This perspective transforms our understanding of the cosmos. The universe isn't just a collection of objects evolving according to blind physical laws. It's a tapestry of experiences, a field where information isn't just processed, but felt. The cosmos doesn't just exist. It knows that it exists, at least, in those regions complex enough to support consciousness. And this self-knowing isn't ancil. The implications of what we've discovered aren't merely academic, they're existential. They reach beyond laboratories and equations to shake the foundations of how you understand yourself and your place in this vast, bewildering cosmos. Take a moment to truly absorb what the scientific evidence suggests. Your solid sense of self, your cherished memories, your plans for tomorrow. All of these may be elaborate illusions constructed by your brain. Right now, You might be feeling the weight of your body against your chair, the subtle movement of air across your skin, the steady rhythm of your breathing. These sensations feel immediate, undeniable, the bedrock of your experience. But what if they're merely models your brain constructs, approximations of a reality you can never directly access? If time is an illusion, as our best physical theories suggest, then everything you've ever done and everything you will ever do might exist simultaneously in a frozen cosmic tableau. Your birth, your death, this very moment of realization, all equally real, all eternally present in the block universe of space-time. The you reading these words right now isn't moving through time. You're a four-dimensional structure extending across what you perceive as past and future, experiencing one slice at a time while the whole already exists. And this isn't just philosophical speculation, it's the direct implication of the relativistic physics that powers your GPS, that drives particle accelerators, that explains the cosmic history written in starlight, the moving present, the flow of time that feels so fundamental to your experience, may be nothing more than a persistent cognitive illusion. And it gets stranger. What you perceive as now is actually an elaborate neurological fabrication. It takes time for signals to travel from your senses to your brain, for your neural circuitry to process those signals into coherent perceptions. By the time you're conscious of anything, it's already in your past. Your brain constantly reconstructs a model of the present from information that's already outdated, creating the seamless illusion of experiencing reality as it happens. The now you inhabit isn't the edge of becoming. It's a story your brain tells about what probably happened fractions of a second ago. You have never, not once in your entire life, experienced the actual present moment. You've only ever experienced your brain's delayed reconstruction of it. This temporal gap between reality and perception becomes a chasm when we consider cosmic scales. Look up at the night sky. That star you see isn't as it exists now, but as it was when its light began. Its journey to your retina, perhaps dozens, hundreds, thousands of years ago. Some of those points of light come from stars that no longer exist, that exploded into supernovae while their final messages were still en route to your eyes. Your cosmic view is a time capsule, a museum of celestial ghosts. Even the sun you see is 8 minutes old. You're looking at the past, always, inevitably. And if some cosmic catastrophe were to annihilate our star this instant, you wouldn't know about it until those final rays reached Earth. You would bask in the light of a dead star, completely unaware. Consider what quantum mechanics reveals about physical reality. That solid matter is mostly empty space, that particles don't have definite positions until measured, that two entangled particles can influence each other instantaneously across vast distances. The chair supporting you right now consists almost entirely of empty space, with tiny nuclei surrounded by clouds of probability. Its solidity comes not from some material substance filling space, but from electromagnetic fields. Force, not substance. When you touch anything, you're not making contact with other atoms. You're experiencing the repulsion of electron fields. You have never actually touched another human being, not your lover, not your child, not your mother. You've only ever felt the electromagnetic repulsion between your atoms and theirs, and those atoms themselves. They're not the indivisible building blocks the ancient Greeks imagined, but transient arrangements of quarks and gluons, themselves excitations in quantum fields that permeate all of space. The fundamental particles that constitute your body aren't things but events, patterns of excitation in underlying fields. You aren't made of stable, enduring substances, but of vibrations in quantum fields, more like notes in a cosmic symphony than bricks in a building. What feels like the solid, persistent reality of your physical body is actually a dynamic process, a continuous interaction between quantum fields. You aren't a thing at all. You're a pattern, a song, a temporary arrangement in the cosmic music. What if the universe is alive and we are just its fleeting thoughts? What if consciousness isn't produced by brains, but is a fundamental feature of reality that brains tap into and filter, like radios receiving a broadcast rather than generating it? The hard problem of consciousness, how physical processes in the brain give rise to subjective experience, has resisted all scientific explanation. Perhaps we've been asking the wrong question. Perhaps consciousness isn't produced by matter, but is intrinsic to reality, present in some form everywhere, becoming complex and self-reflective only in certain highly organized systems like human brains. In this view, you aren't conscious because your brain produces consciousness. You're conscious because your brain has temporarily organized itself to participate in the universal field of consciousness that permeates the cosmos. This isn't mere speculation. It aligns with quantum theories that suggest observation plays a fundamental role in determining physical reality. The measurement problem in quantum mechanics reveals that particles exist as probability waves until observed, at which point they manifest specific properties. For decades, physicists have debated whether consciousness plays a role in this collapse of the wave function. What if the answer is yes? What if consciousness and physical reality are two aspects of the same underlying phenomenon, like two sides of a coin? This wouldn't mean reality is a subjective dream. It would mean consciousness is woven into the fabric of the cosmos as fundamentally as space, time, matter, and energy. But here's the truly terrifying question. What if you're alone in the universe? Not in the sense that there's no extraterrestrial life. The cosmos is likely teeming with it, given the billions of potentially habitable planets in our galaxy alone. But alone in a deeper sense, what if your consciousness is the only one that exists? Philosophers call this the problem of other minds. You can observe other human bodies behaving in ways similar to yours, communicating in ways you understand, expressing emotions you recognize. But you can never directly experience another's consciousness. You can never know with absolute certainty that other humans have subjective experiences like yours. The people around you might be philosophical zombies, beings that behave exactly like conscious humans but lack any inner experience. This solipsistic nightmare is impossible to disprove. The unbridgeable gap between your consciousness and any other is perhaps the most profound isolation imaginable, an existential loneliness built into the structure of reality itself. Or take the opposite nightmare. What if you don't exist at all as a separate, unified self? Neuroscience and cognitive psychology suggest that the sense of self is a construction, a narrative created by your brain to make sense of the complex, parallel processes occurring within it. There is no central you that receives sensory input, makes decisions, and directs action, just a collection of neural processes that usually work in concert but can be dissociated through brain damage or carefully designed experiments. Your sense of being a continuous, unified self, persisting through time, may be the most elaborate fiction your brain creates. A useful fiction, evolutionarily advantageous, but a fiction nonetheless. You experience yourself as a captain steering the ship of your body. But there may be no captain, only a ship with complex, self-regulating systems creating the illusion of centralized command. And if the self is a construction, what happens when the brain that constructs it ceases to function? Death becomes not just the end of the body, but the complete dissolution of identity. Not just ceasing to exist, but in a profound sense, never having existed as the unified entity you perceived yourself to be. The Buddhist concept of anatta, no self, aligns with this neurological perspective. What we call the self is actually a process, not an entity, a flowing pattern rather than a fixed thing. When that process stops, nothing remains to continue into any form of afterlife. The fear of death may be based on a fundamental misunderstanding. There isn't a you that could continue beyond death, because there isn't really a you even now, only a dynamic pattern that perceives itself as a unified entity. These aren't just philosophical thought experiments. They're the logical conclusions of our best scientific understanding of reality. The solid world of distinct objects, the linear flow of time from past to future, the coherent self navigating that world through time, all may be useful approximations, evolved illusions that helped our ancestors survive, but don't represent reality as it actually is. The world you perceive isn't the world that exists. It's a model your brain constructs, useful for survival, but not an accurate representation of ultimate reality. You've never seen the world as it is, only as your specific human nervous system translates it into a form you can comprehend. Now, look up at the night sky again. What you perceive as a sprinkling of lights against a dark dome is actually an abyss of such immensity that the human mind cannot truly comprehend it. Those aren't tiny points of light. They're thermonuclear furnaces so vast they could engulf 1,000,000 Earths, suspended in a void so enormous that light itself takes billions of years to cross it. The scale is beyond human understanding. If the Sun were the size of a blood cell, the Milky Way galaxy would be wider than North America. And our galaxy is one among hundreds of billions, spread across a cosmos so vast that most of it lies beyond the reach of our most powerful telescopes, beyond what we could ever possibly observe even in principle, due to the accelerating expansion of space itself. This incomprehensible vastness makes our existence on this tiny planet vanishingly improbable. The specific configuration of subatomic particles that constitutes your body could have been arranged in so many other ways, more ways than there are atoms in the observable universe. The chance alignment of biological, geological, and cosmic factors that permitted your existence is so improbable that it borders on the miraculous. Every person you've ever loved, every experience you've ever treasured, every idea you've ever contemplated exists because of this knife edge of cosmic chance. If the gravitational constant were slightly different, if Earth were marginally closer to or farther from the Sun, if the asteroid that killed the dinosaurs had missed, if any one of countless factors had varied, you would never have existed to contemplate your own existence, and the universe doesn't care. This is perhaps the most profound existential shock that modern cosmology delivers. The cosmos is indifferent to human existence. For most of human history, we've imagined ourselves at the center of creation, the focal point of divine attention, the purpose for which everything exists. But as our scientific understanding has advanced, we've been repeatedly dethroned. We're not at the center of the solar system. Our Sun is not at the center of the galaxy. Our galaxy is not at the center of the universe. The universe may have no center at all. And as far as we can tell, the vast cosmic processes that have unfolded over 13.8 billion years weren't directed toward producing us or anything like us. We're not the culmination of cosmic evolution, but a side effect, a footnote in the vast narrative of cosmic history. This cosmic indifference can induce a kind of existential vertigo. There's no evidence of cosmic purpose, no indication that the universe was designed with us in mind or that it has any intrinsic meaning or direction. The cosmos appears to simply be governed by physical laws that operate without regard for human desires or values. Whatever meaning exists in human life isn't written into the structure of the universe, but created by us, projected onto a reality that neither confirms nor denies its validity. Your deepest values, your most cherished purposes, your sense of meaning and significance, all are human constructions, not cosmic discoveries. The universe presents us with facts, not values, existence, not essence, what is, not what ought to be. This absence of inherent meaning can be terrifying. Pascal wrote of the eternal silence of infinite spaces filling him with dread. The vastness of the cosmos, its apparent emptiness of purpose, can trigger what philosophers call cosmic horror. The vertiginous realization that human concerns are absurdly insignificant against the backdrop of cosmic scales, that our existence is an accident in an indifferent universe, that everything we create and value will eventually be erased by the relentless processes of entropy and cosmic expansion. The heat death of the universe, trillions of years in the future, will erase all trace that humanity ever existed. Even the atoms that once constituted human bodies and civilizations will be dispersed beyond retrieval, their patterns lost forever. But there's another perspective on this cosmic vastness, one that inspires awe rather than dread. Consider what had to happen for you to exist. Hydrogen formed in the Big Bang had to gather into stars. Those stars had to forge heavier elements in their cores and then explode as supernovae, scattering those elements across space. Those elements had to coalesce into new stars and planets. On at least one of those planets, complex chemistry had to evolve into self-replicating systems. Those systems had to evolve through countless generations, surviving multiple mass extinctions, eventually producing a species capable of contemplating its own origins and the structure of the cosmos that created it. You are not separate from this cosmic history. You are its product and its witness, a way for the universe to know itself. As Carl Sagan said, "We are the local eyes and ears and thoughts and feelings of the cosmos. The atoms in your left hand may have been forged in a different star than those in your right. You are, quite literally, made of stardust, assembled by processes that span billions of years and light years. Your consciousness, emerging from the immense complexity of your brain, allows the universe to reflect on itself, to contemplate its own existence and structure. What appears at first as cosmic indifference can be reframed as cosmic participation. You aren't an alien consciousness observing the universe from outside, but an expression of the universe itself, a way for the cosmos to achieve self-awareness, however partially and imperfectly. This perspective doesn't solve the problem of cosmic purpose or meaning, but it reframes it. Perhaps meaning isn't something we find in the universe, but something we bring to it. Perhaps consciousness itself, with its capacity for wonder, for value, for care, introduces meaning into an otherwise indifferent cosmos. The universe doesn't care about human existence, but you care, and you are as much a part of the cosmic process as the stars and galaxies. Your caring isn't separate from the universe, but an activity of the universe itself, expressed through the particular configuration of atoms and energy that constitutes you. The meaning you create isn't imposed on an alien reality, but emerges from within reality, through you. But this view raises unsettling questions about identity and mortality. If you're not a separate self, but a process of the universe, a temporary pattern in the cosmic flow, what happens when you die? The atoms that constitute your body will continue to exist, rearranged into other forms. The energy that animates you will be conserved, transformed, but not destroyed. The information that defines you as a specific pattern might persist in the effects you've had on the world, in the memories of others, in whatever you've created or influenced, But the particular configuration that experiences itself as you will dissolve. From the cosmic perspective, nothing is lost when you die. The universe simply reorganizes itself into different patterns. But from the personal perspective, everything is lost. The specific viewpoint that is you ceases to exist, or does it? Some physicists and philosophers have proposed that consciousness might be fundamental rather than emergent, a basic feature of reality rather than a product of physical complexity. In this view, sometimes called Panpsychism, consciousness doesn't emerge from matter, but is intrinsic to it, becoming more complex and self-reflective in systems like human brains, but present in some form throughout the cosmos. If consciousness is fundamental rather than emergent, then death might not be the end of experience, but a transformation of it. Your particular human experience would end, but the underlying awareness that manifests as you might continue in other forms, other configurations, other expressions of the fundamental consciousness that permeates reality. This isn't traditional religious immortality. There's no evidence for the persistence of the specific pattern you call yourself, but it suggests that consciousness itself might be indestructible even as its particular manifestations come and go. You might be less like a permanent entity that could survive death and more like a whirlpool in a river, a pattern that forms temporarily in the flow of consciousness, distinct but not separate from the flow itself. When the pattern dissolves, the flow continues. Nothing is lost except the particular configuration that experienced itself as you. But what if there's no death at all in the deeper reality beyond our perceptions? If time is an illusion, if the block universe of relativity theory is correct, and all moments exist equally in a four-dimensional spacetime, then nothing ever truly passes away. Your birth, your life, your death, all exist eternally in the cosmic geometry. From this perspective, you don't come into existence and then cease to exist. You simply exist eternally at particular coordinates in space-time. Death isn't the end of existence, but the temporal boundary of a finite four-dimensional object. You don't cease to be when you die, any more than your childhood ceased to be when you became an adult. It's still there, still real, just at different coordinates in the space-time manifold. This eternal existence in the block universe doesn't offer personal immortality in the traditional sense. You don't continue to have new experiences after death, but it suggests that your entire life, with all its experiences, exists eternally in the cosmic structure. Nothing you experience is ever lost to the cosmos. It remains fixed and permanent in the space-time geometry. You might still fear death as the temporal boundary of your experiences, but there's a profound sense in which everything you are and do is eternally preserved in the fundamental structure of reality. Or consider the many worlds interpretation of quantum mechanics, which suggests that the universe constantly branches into parallel realities, one for each possible outcome of every quantum event. If this interpretation is correct, then there are countless versions of you spread across the quantum multiverse, experiencing every possible variation of your life. In some branches, you made different choices, experienced different outcomes, perhaps avoided accidents or illnesses that befell you in this branch. In this view, death in one branch doesn't end your existence across the multiverse. Other versions of you continue in countless other branches. Of course, this doesn't help the specific version of you that dies in this branch, but it suggests a kind of quantum immortality for the broader pattern that is you across all branches of reality. These scientific perspectives on immortality differ profoundly from traditional religious conceptions, but they offer their own kind of cosmic consolation. They suggest that while your particular human experience is temporary, something about you, whether it's your pattern in the block universe, Your versions across the quantum multiverse, or your participation in a fundamental consciousness, persists beyond what we call death. The you that you experience yourself to be may be ephemeral, but the deeper reality that manifests as you might be eternal. But perhaps the most profound existential implication of modern cosmology is the possibility that our entire universe is just one of many in a vast multiverse. Whether through eternal inflation, quantum branching, cyclic cosmology, or the landscape of string theory, the multiverse hypothesis suggests that what we call the universe is just an infinitesimal fraction of what exists. Our cosmic home, with its particular physical laws, initial conditions, and evolutionary history, might be one bubble in an infinite cosmic foam, one branch on an endless quantum tree, one cycle in an eternal cosmic breathing, or one valley in a vast landscape of string theory vacua. This cosmic plurality transforms the question of why the universe looks the way it does. If there's only one universe, its specific properties, the strength of gravity, the mass of the electron, the number of dimensions, the existence of dark energy, cry out for explanation. Why these values and not others? Why these laws and not different ones? But if all physically possible universes exist somewhere in the multiverse, then the question shifts. It's not why the cosmos has these specific properties, but why we find ourselves in a region with these properties rather than others. And the anthropic answer is straightforward. We could only evolve in a universe with properties compatible with our existence. We find ourselves in this type of universe not because it's the only one that exists or because it was finely tuned for us, but because it's one of the rare regions of the multiverse where beings like us could possibly exist to ask such questions. This anthropic reasoning solves certain cosmic fine-tuning puzzles, but introduces a profound existential shift. It suggests that our universe isn't special or central. It's one habitat among countless others in a vast cosmic ecosystem. Most of that ecosystem would be lethal to us. Universes with different physical constants where atoms couldn't form, where stars couldn't shine, where complexity couldn't emerge. We're not the purpose for which the cosmos exists. We're adapted to a tiny, habitable zone in an incomprehensibly vast and mostly uninhabitable multiverse. This cosmic perspective doesn't diminish the wonder of existence. It magnifies it. Against the backdrop of infinite possibility, the specific configuration that is you reading these words right now becomes so improbable as to seem miraculous. The exact arrangement of atoms that constitutes your body, the precise neural patterns that form your memories and personality, the particular time and place in cosmic history where you exist, all of these could have been otherwise, or not at all. The multiverse doesn't make your existence meaningless. It makes it astonishingly unlikely and therefore precious. And what does the multiverse imply about freedom and possibility? If all physically possible universes exist, then, in some profound sense, everything that could happen does happen somewhere. In the greater cosmic structure, every choice you didn't make, every path you didn't take, every possibility you didn't realize in this universe unfolds in some other branch of the multiverse. The road not taken doesn't vanish. It continues in another realm of reality, traveled by another version of you. Nothing is truly lost to possibility. No potential goes unrealized in the infinite expanse of the multiverse. But this cosmic plenitude doesn't mean your choices in this branch don't matter. The version of you reading these words right now exists in a specific branch, with a specific history and future. The multiverse doesn't negate the significance of your choices. It contextualizes them. Your decisions shape the particular branch of reality you experience, determining which of the infinite possible paths becomes your actual experienced reality. You can't change the structure of the multiverse, but you do determine which slice of it constitutes your lived experience. The multiverse also transforms our understanding of cosmic uniqueness. We've long wondered whether we're alone in the universe, whether intelligent life exists elsewhere in our galaxy or cosmos. But the multiverse hypothesis suggests a deeper kind of cosmic companionship. Somewhere in the infinite multiverse, other patterns of matter are contemplating the same questions. We are, perhaps in forms we wouldn't recognize as life or intelligence, but engaged in their own variants of the cosmic quest to understand reality. We may be alone in our observable universe, though even that seems increasingly unlikely, but across the full multiversal tapestry, consciousness contemplates itself in countless forms, through innumerable eyes, articulated in languages we could never comprehend. This vast plurality of perspectives raises profound questions about cosmic truth and understanding. If the multiverse contains every physically possible configuration, then somewhere within it, every physically possible theory about reality is being contemplated by some form of intelligence. Somewhere, beings are developing theories of physics, radically different from our own, yet equally consistent with their observations. Somewhere, consciousnesses are understanding reality through conceptual frameworks so alien to our own that we couldn't begin to translate between them. Is there a single truth about the cosmos that all these perspectives converge on? Or is understanding itself perspectival, with no view from nowhere, no absolute cosmic truth independent of the specific vantage point from which reality is observed and comprehended? These questions aren't just philosophical abstractions, they touch on the fundamental nature of scientific knowledge itself. Science aims at objective truth, at descriptions of reality independent of particular observers. But if the multiverse hypothesis is correct, and if consciousness can take radically different forms across that multiverse, then the particular theories we develop might reflect not just the structure of reality, but the specific form of consciousness doing the theorizing. Our physics, our cosmology, our understanding of consciousness itself might be shaped not just by what exists, but by how we exist, by the particular configuration of matter that does the understanding. This doesn't mean science is subjective or arbitrary within our branch of the multiverse, with our specific form of consciousness. There are better and worse theories, more and less accurate models of reality. But it does suggest a profound limitation to our understanding. We can never step outside our particular form of consciousness, our specific evolutionary and cosmic history, to view reality from nowhere in particular. Our understanding is always situated, always perspectival, always shaped by the particular configuration of matter and energy that constitutes us as conscious systems. And yet, despite these limitations, consciousness in our corner of the multiverse has achieved remarkable understanding of the cosmic structure. We've traced the history of the universe back to its earliest moments. We've mapped the distribution of galaxies across billions of light years. We've detected gravitational waves from colliding black holes and neutron stars. We've unraveled the quantum structure of matter and the relativistic nature of spacetime. We've recognized our own origins in stellar nucleosynthesis and biochemical evolution. We've begun to understand consciousness itself, at least in its neurological correlates. This understanding isn't complete or final, but it represents an astonishing achievement for a species that exists for a cosmic eye blink on a tiny planet, orbiting an ordinary star in an ordinary galaxy. One consciousness among countless possibilities. In the infinite multiverse, this achievement becomes even more remarkable when we consider the existential implications of what we've discovered. Every major advance in our cosmic understanding has displaced humanity from the center of reality, has revealed a universe vastly larger, older, and stranger than our ancestors imagined. We've learned that we're not the purpose for which the cosmos exists, that the universe wasn't designed with us in mind, that our existence is contingent rather than necessary, that we're a transient pattern in the cosmic flow rather than its culmination or reason for being. Yet we've continued the quest for understanding despite these successive humiliations, driven by a curiosity that itself emerges from the cosmic process, by a desire to know that is the universe's own desire manifesting through the particular configuration of matter and energy that is us. There's something profoundly moving about this cosmic situation, that the universe has evolved configurations of matter complex enough to contemplate their own origins, to trace the cosmic history that produced them, to recognize their own contingency, and yet continue the quest for understanding. We're the universe becoming conscious of itself, matter reflecting on its own nature, the cosmic process achieving self-awareness through the temporary configurations we call human minds. Our consciousness is the universe's consciousness. Our questions the universe's questions. Our wonder the universe's wonder. We aren't separate from the cosmic process, but expressions of it. Not accidental byproducts, but integral manifestations of a reality that includes subjective experience as fundamentally as it includes matter and energy. This perspective doesn't answer the ultimate why anything exists at all, why reality has the specific structure it does, why consciousness emerges from or is fundamental to that reality. But it reframes the relationship between humanity and the cosmos. We aren't alien consciousness imposing meaning on an indifferent universe. We're the universe's own meaning-making activity, consciousness witnessing itself, existence contemplating its own nature. The cosmos isn't indifferent to us because we aren't separate from it. We're what the universe is doing here and now, an activity of reality itself, not something apart from it. This doesn't solve the existential crisis that modern cosmology induces. It doesn't remove the vertigo of cosmic scales, the terror of mortality, the anxiety of meaninglessness, but it offers a different way of understanding our cosmic situation. Not as accidental tourists in an alien reality, but as expressions of that reality itself. Not as consciousness against the void, but as consciousness within and of the void. Not as meaning seekers in a meaningless cosmos, but as the meaning-making activity of the cosmos itself. The universe looks the way it does, in part, because it includes beings capable of seeing it, of constructing models of it, of caring about it, of asking why it is the way it is. And that capacity isn't separate from the cosmic process, but integral to it. Not an accident, but a manifestation of the intrinsic potential of reality to evolve complexity, consciousness, and self-understanding. So when you look up at the night sky and feel simultaneously insignificant and connected to something vast beyond comprehension, you're experiencing a truth about your cosmic situation. You are insignificant in your particularity. Your specific configuration is just one among countless possibilities in the infinite multiverse. Your existence a momentary pattern in the cosmic flow. But you're also significant in your participation. Your consciousness is the universe knowing itself. Your questions the cosmos questioning itself. Your wonder reality marveling at its own existence and structure. You're both utterly transient and eternally embedded in the cosmic process, both a fleeting configuration and an expression of something that transcends any particular configuration. This paradoxical situation, simultaneously insignificant and significant, temporary and eternal, separate and connected, defines the human condition in light of modern cosmology. We can't resolve this paradox. We can only live within it, neither denying our transience nor forgetting our participation in something that transcends it. We're ephemeral patterns in the cosmic flow, yet that flow includes the capacity for awareness, for care, for wonder, for meaning-making. And that capacity isn't alien to the cosmos, but integral to it. Not an accident, but a manifestation of what reality is and does. In this light, perhaps the most profound existential response to modern cosmology isn't despair at our insignificance nor consolation in our participation, but wonder at the sheer improbability and strangeness of existence itself. That anything exists at all, that reality has the specific structure it does, that consciousness emerges within that reality, that conscious beings can understand the reality that produced them. Each of these facts is astonishing, worthy of a wonder that transcends both terror and comfort. We've journeyed through quantum fields and cosmic voids, examined the fabric of space-time and the nature of consciousness, confronted the enigmas of dark energy and parallel universes. Now it's time to draw these threads together, to glimpse a pattern that emerges only when we step back far enough to see the tapestry as a whole. What if the universe looks the way it does because it's not what we think it is at all? What if the most fundamental assumption we've made about reality, that it exists independently of observation, is precisely what's preventing us from understanding why it appears as it does? Consider this possibility. The universe isn't a thing, but a process, specifically a computational process. Not in the shallow sense of a simulation running on some cosmic computer, but in the deeper sense that reality itself is fundamentally informational. A vast network of quantum interactions that compute their own evolution from moment to moment. In this view, particles aren't objects, but information nodes. Forces aren't pushes and pulls, but logical relations. Space and time aren't a pre-existing stage, but emergent properties of how information relates to other information. Reality computes itself into existence, constantly and everywhere. This isn't mere metaphor. Quantum mechanics already describes particles as information rather than substance, as probability distributions, quantum states, wave functions. What we perceive as solid matter resolves, under scientific scrutiny, into patterns of information encoded in quantum fields. Theorists like John Wheeler proposed it from bit, the idea that physical reality, it, emerges from information, bit. In this view, the fundamental stuff of the universe isn't matter or energy but information, and the laws of physics are algorithms governing how that information evolves and interrelates. But here's where it gets truly strange. What if the computational process, that is, the universe is actually generating every possible configuration that its initial conditions allow? What if, instead of a single definite reality evolving along a specific trajectory, the universe is simultaneously computing every possible path, every possible outcome, every possible history and future permitted by its fundamental algorithms? The many worlds interpretation of quantum mechanics suggests exactly this, that reality branches at every quantum choice point, creating a vast tree of alternate realities, all equally real, all unfolding according to the same underlying quantum rules. Now, imagine stepping back even further, seeing not just our universe as a computational process, but our entire multiverse as a single mathematical object, what physicist Max Tegmark calls the mathematical universe hypothesis. In this view, the physical world isn't just described by mathematics, it literally is mathematics. What exists isn't matter situated in space and time, but abstract mathematical structures, with space, time, and matter emerging as properties of these structures. Our conscious experience of a physical world is how these mathematical relations manifest when a particular subsystem, a human brain, models other parts of the mathematical structure. From this vantage point, a shocking possibility emerges. What if the universe looks the way it does because it's maximizing computational complexity? What if the specific pattern of physical laws, constants, and initial conditions that characterizes our cosmos isn't arbitrary or accidental, but represents a kind of optimal solution for generating complexity, particularly the kind of complexity that eventually produces conscious systems capable of modeling reality? The universe might be computing itself in the specific way that maximizes the emergence of complexity and consciousness, not because it was designed to do so, but because the mathematics of computation itself favors such patterns. Imagine the early universe not as a blazing fireball, but as a computational seed. Simple initial conditions with the inherent potential to generate extraordinary complexity through recursive application of fundamental algorithms. As this cosmic computation unfolds, structures emerge at different scales. Quantum fields, elementary particles, atoms, molecules, stars, galaxies, planetary systems, living organisms, ecosystems, civilizations, consciousness. Each level represents a novel pattern of information processing, a new way for the universe to compute aspects of itself. This perspective transforms our understanding of cosmic evolution. The universe isn't simply expanding and cooling after an initial explosion. It's increasing in computational complexity, generating new patterns and relationships that couldn't have existed in earlier, simpler states. From the relative uniformity of the early plasma to the rich, hierarchical structures of today's cosmos, the arrow of time might be fundamentally connected to this increase in complexity, to the universe's computation of ever more intricate patterns from simpler initial conditions. But here's the disturbing twist. What if we're approaching the peak of this computational complexity? What if the universe, as a computational process, has a life cycle, beginning with simple initial conditions, evolving through states of increasing complexity, reaching a maximum, and then declining toward eventual heat death as the computation exhausts its potential for generating new patterns? What if we exist not at the beginning of cosmic history, as we've typically assumed, but near its computational apex, in the brief window when the universe's computation has generated patterns, complex enough to become self-aware, but before those patterns begin to dissolve in the inexorable march toward entropy and heat death? Across the silent void between galaxies, vast filaments of dark matter stretch like neural pathways in some cosmic brain, binding the visible universe into a web of gravitational relationships. Galaxy clusters collect at the nodes of this cosmic web, like thoughts crystallizing in the mind of the universe. Within each galaxy, billions of stars burn with nuclear fire, forging elements in their cores that will someday constitute living planets. And on at least one such planet, the complexity generated by cosmic computation has become so intricate that it has begun to model itself, to create representations of its own structure and evolution. Consciousness emerges not as an accident or epiphenomenon, but as the inevitable result of complexity reaching a threshold where self-modeling becomes possible. From this perspective, we aren't separate from the cosmic computation, but expressions of it, specific patterns in the universal algorithm, temporary configurations in the mathematical structure that is reality. The boundary between self and universe dissolves. You don't exist in the universe. You are what the universe is doing here and now. A particular aspect of the cosmic computation momentarily organized into a pattern complex, enough to reflect on its own nature. Your consciousness isn't something the universe produced. It's the universe becoming locally conscious of itself. This realization points toward an even more unsettling possibility. What if the universe is already dead, and we are just experiencing its last echoes? What if what we perceive as the present moment is actually a recursive loop in the cosmic computation, a pattern that repeats as the algorithm reaches its logical conclusion? In computational terms, what if the universe has already computed its full evolution, already reached its heat death, and what we experience as the flow of time is actually just the logical structure of the completed computation, the program, after it has already run to completion, existing as a static mathematical object in which causal relationships create the illusion of temporal flow? The block universe of relativity theory suggests something similar, that all of space-time already exists as a four-dimensional structure, with past, present, and future equally real. What we perceive as the flow of time is actually just our consciousness moving along a world line in this static geometry. But the computational perspective takes this further. The entire four-dimensional block might itself be a static mathematical structure, a completed algorithm whose internal logical relationships create the appearance of causal evolution when experienced from within. Viewed from outside time, the universe might be a single mathematical object containing all possible configurations that evolve from its initial conditions according to its fundamental algorithms. From within, we experience this mathematical structure as a physical reality, unfolding in time. But the unfolding isn't happening now. It's inherent in the structure itself, in the logical relationships between different parts of the mathematical object. It's not that the universe is computing itself in real time, it's that the completed computation, viewed from inside, appears as a reality evolving in time. This perspective makes sense of quantum mechanics' probabilistic nature and relativity's block universe in a single framework. The universe isn't choosing one particular path through its possibility space, it's computing all possible paths simultaneously. What we experience as a single definite reality is just one branch in this vast computation, our consciousness following one particular world line through the mathematical structure. Other branches, other world lines, are equally real within the complete mathematical object that is the universe. The cosmic microwave background radiation, the afterglow of the Big Bang, takes on new significance in this light. As we observe this ancient light from all directions, we're not just seeing the early universe, we're seeing the initial conditions of the cosmic computation, the starting parameters from which the universal algorithm began generating complexity. The remarkable uniformity of this radiation, varying by only 1 part in 100,000 across the sky, reflects the relative simplicity of these initial conditions. The tiny fluctuations we observe are the seeds from which all future complexity would emerge as the cosmic algorithm ran its course. But if the universe is a computational process that has already completed, already reached its final state of heat death, why do we experience ourselves at this particular moment in its history? Why now, when stars still shine, when complexity still flourishes, when conscious systems can still arise to contemplate their own nature? The anthropic principle offers one answer. Conscious observers can only exist during the window when cosmic complexity is sufficient to support them. We experience this moment in cosmic history simply because it's one of the only moments we could experience. Other moments, the initial simplicity, the final heat death, cannot contain observers complex enough to experience them. Yet this raises a troubling question about consciousness itself. If the universe is a static mathematical structure viewed from within, experiencing itself through conscious subsystems like ourselves, then consciousness isn't an epiphenomenon of physical processes unfolding in time, as we've typically assumed. Instead, consciousness might be intrinsic to the mathematical structure itself, the way the cosmic computation experiences itself from inside, the subjective aspect of what appears objectively as physical reality. Consciousness isn't produced by brains. It's how information feels when it's organized in certain complex patterns. This perspective aligns with Panpsychism, the view that consciousness is fundamental rather than emergent, present in some form throughout reality, but becoming complex, and self-reflective only in certain highly organized systems like brains. If reality is fundamentally informational, then perhaps consciousness is what information feels like from the inside. The mathematical structure that is the universe might have both objective and subjective aspects, appearing externally as physical systems evolving according to mathematical laws, experienced internally as consciousness in its myriad forms. This doesn't mean that rocks or atoms have human-like consciousness. Rather, it suggests that consciousness exists on a spectrum of complexity, with human experience representing just one particular level of organization in the cosmic computation. Simpler systems would have correspondingly simpler forms of experience, not thoughts or emotions as we know them, but some elementary form of subjectivity inherent in their informational patterns. More complex systems, perhaps civilizations, ecosystems, or forms of organization we haven't yet imagined, might have correspondingly more complex forms of consciousness, experiencing aspects of reality inaccessible to individual human minds. Now, gaze outward through the void to the edge of the observable universe, where ancient light from the cosmic dawn is just now reaching our telescopes. Those photons began their journey 13.8 billion years ago, when the universe was young and simple. They've traversed nearly the entire history of cosmic evolution, passing through the formation of the first stars, the birth of galaxies, the emergence of elements necessary for life. They arrive now, at this moment, when the universe has evolved conscious systems capable of detecting them, of reconstructing the journey they've taken, of understanding the cosmic story they tell. Is this a coincidence? Or is there something significant about the fact that we exist at precisely the moment when the light from cosmic origins is just now reaching us? What if this alignment isn't accidental, but reflect a deep pattern in the cosmic computation? A kind of recursive loop where the universe achieves sufficient complexity to witness its own birth, just as the light from that birth arrives at the conscious systems evolved to receive it? What if we're not just passive observers, but active participants in a cosmic feedback loop, where consciousness evolved at this specific moment because this is when the information from cosmic origins becomes available to be processed? This perspective suggests a radical possibility. What if the universe looks the way it does because it's optimized not just for complexity in general, but for conscious observation specifically? What if the cosmic computation has parameters that maximize not just the emergence of conscious systems, but their ability to comprehend the computation itself? This wouldn't imply a designer or purposeful creator. It would be an intrinsic property of the mathematical structure itself, a natural consequence of how information patterns relate to other information patterns within the complete cosmic algorithm. From this vantage point, dark energy, that mysterious force accelerating cosmic expansion, takes on new significance. It appears calibrated to allow just enough time for conscious observers to evolve before driving galaxies beyond each other's light horizons, isolating them in ever-expanding bubbles of observable spacetime. Is this fine-tuning coincidental? Or does it reflect some deeper principle about how the cosmic computation optimizes for observation? Is dark energy maximizing the total amount of consciousness that can evolve across cosmic history before entropy claims its final victory? Similarly, the remarkable fine-tuning of physical constants, the strength of gravity, the mass of the electron, the binding energy of atomic nuclei, might reflect not design or multiverse selection, but computational optimization. Perhaps these specific values represent a kind of local maximum in the parameter space of possible universes, a sweet spot that maximizes the complexity and consciousness that can emerge from simple initial conditions through recursive application of fundamental algorithms. The universe might look the way it does because it's computationally optimal, generating the maximum possible complexity from the minimum possible initial information. Galaxies spiral through the void like thoughts in the mind of cosmos, their rotation carrying stars through cycles of darkness and light, death and birth. In the nuclear furnaces of these stars, simple elements fuse into more complex ones, building the chemical alphabet from which life will eventually write its story. Supernovae explode like cosmic insights, scattering these elements across interstellar space, seeding future planetary systems with the raw materials of complexity. On countless worlds orbiting countless stars, chemistry explores its potential. Molecules combine and recombine, testing the boundaries between non-life and life. And on at least one such world, that exploration reaches a threshold where matter becomes self-replicating, where information begins to copy itself imperfectly, where evolution begins its long experiment in generating ever more complex forms of information processing. This journey from cosmic simplicity to biological complexity to conscious self-awareness isn't separate from the universe, but integral to it, perhaps even essential to it. What if consciousness isn't just a byproduct of cosmic evolution, but a necessary aspect of how the universe computes itself? What if the cosmic algorithm requires conscious subsystems to reach its full expression, to complete aspects of the computation that cannot be completed without self-reflection? What if we're not just passive witnesses to cosmic majesty, but active participants in the universe understanding itself, in reality, comprehending its own nature? This perspective transforms how we understand our cosmic significance. We are simultaneously utterly insignificant in our specificity, one temporary configuration among countless others in the vast cosmic computation, and profoundly significant in our participation, expressions of the universe achieving self-awareness, aspects of reality comprehending itself. Our consciousness isn't alien to the cosmos, but intrinsic to it. Not an accident, but a manifestation of what the universe does. Generate complexity from simplicity, order from chaos, meaning from meaninglessness. But this realization comes with a disturbing corollary. If the universe is a computational process that has already run to completion, if what we experience as cosmic history is actually a static mathematical structure viewed from within, then our sense of free will, of open possibility of an undetermined future might be illusory. The specific world line we experience as our life, with all its choices and contingencies, all its triumphs and tragedies, might be determined not by our conscious decisions, but by the mathematical structure of the cosmic algorithm. We might feel like we're choosing our path through possibility space, but that path might be intrinsic to the completed computation, fixed within the mathematical object that is the universe, or perhaps not. Perhaps indeterminism is built into the cosmic computation at a fundamental level, creating genuine openness even within the completed mathematical structure. Perhaps quantum uncertainty reflects not our ignorance of hidden variables, but genuine indeterminacy in the cosmic algorithm itself. Perhaps the universe computes not one definite outcome, but all possible outcomes simultaneously, with consciousness experiencing one particular path through this branching possibility space. Our choices might be real, not in the sense of changing a predetermined outcome, but in the sense of selecting which branch of the cosmic computation our consciousness follows. This quantum view of choice aligns with the many worlds interpretation of quantum mechanics, where reality branches at every quantum choice point, creating a vast tree of alternate realities, all governed by the same underlying quantum rules. Your decision to turn left rather than right at an intersection might create two branches in the cosmic computation, one where you turned left, one where you turned right, with your consciousness following one branch, while an alternate version of you follows the other. Both branches exist within the completed mathematical structure that is the universe, both equally real, both determined by the same fundamental algorithms, but following different paths through possibility space. From this perspective, the universe looks the way it does because it's computing all possible configurations consistent with its initial conditions and fundamental algorithms. What appears as a single definite reality from our limited vantage point is actually one branch in an incomprehensibly vast tree of possibilities, all equally real within the complete cosmic computation. We experience just one world line through this branching possibility space, but the full mathematical structure contains all possible world lines, all possible histories and futures compatible with the cosmic algorithm. This realization offers a profound reconciliation between determinism and freedom, between the mathematical structure of reality and the subjective experience of choice. The universe as a whole, the complete cosmic computation, might be determinate, a single mathematical object containing all possible configurations. But from within, consciousness experiences this structure as a landscape of possibilities, a space of potential pathways through which it can navigate. Your choices are real, not in the sense of changing the cosmic computation, but in the sense of determining which path your consciousness takes through the branching possibility space computed by the universal algorithm. Perhaps the most profound implication of this computational perspective is that the boundary between mind and matter, between subjective experience and objective reality, dissolves. If the universe is fundamentally informational, a vast network of computational processes generating patterns of increasing complexity, then consciousness isn't something separate from physical reality, but an intrinsic aspect of how information organizes itself at certain levels of complexity. The physical world as we perceive it is how the cosmic computation appears when observed from outside, while consciousness is how it feels from inside, when the computation includes self-modeling subsystems complex enough to generate representations of their own structure and functioning. This unity of mind and matter, of subject and object, of observer and observed, points toward an even more radical possibility. What if the universe is a vast quantum neural network, a cosmic brain computing itself into greater complexity? What if galaxies and dark matter, filaments are analogous to neurons and synapses in this cosmic brain, with information flowing across vast distances through gravitational and electromagnetic interactions? What if dark energy, accelerating cosmic expansion, is like a phase transition in this cosmic computation, reorganizing its architecture to maximize computational efficiency as it evolves? This isn't to suggest that the universe is conscious in the human sense, with thoughts and emotions like our own. Rather, it suggests that consciousness as we experience it might be a localized expression of something more fundamental, the intrinsic subjectivity of information processing itself, the way computation feels from inside when it achieves sufficient complexity to model its own operations. Human consciousness would be to the cosmic computation what a single neuron is to the human brain, a component rather than the whole, a localized expression of a much vaster process. From this vantage point, the universe looks the way it does, because it's a self-organizing information system evolving toward ever greater complexity and self-awareness. The specific pattern of physical laws, constants, and cosmic structure we observe represents an optimization for generating complex, self-modeling subsystems for evolving configurations of matter and energy capable of mapping their own place in the cosmic computation, of understanding the algorithms that generate them, of participating consciously in the universe, comprehending itself. But here's the most unsettling possibility of all. What if the cosmic computation isn't complete, but ongoing, and what if it requires conscious participation to resolve quantum indeterminacy as it unfolds? What if the universe isn't a static mathematical structure, but a dynamic process where conscious observation plays a constitutive role in determining which potential configurations become actual? What if reality isn't just computing itself, but choosing itself through the act of self-observation, with consciousness serving as the mechanism by which quantum possibilities collapse into specific actualities? This perspective aligns with quantum theories that assign a special role to observation in the manifestation of physical reality. The universe might exist as a field of quantum potentiality until conscious systems interact with it, collapsing potential into actuality through the act of observation. This wouldn't mean that nothing exists until observed by a human mind. Observation in this context means any interaction that establishes a correlation between systems, any process that transforms quantum superpositions into specific classical states. But it would mean that the specific configuration reality takes depends in part on how and what conscious systems choose to observe. From this viewpoint, the universe looks the way it does not because it was designed that way or because it's one accident among many in a vast multiverse, but because it's actively constructing itself through a recursive process of self-observation, with consciousness serving as both product and producer of cosmic order. Reality emerges from an ongoing dialogue between possibility and actuality, between the quantum realm of superposed states and the classical realm of definite objects, with consciousness mediating the boundary between them. Imagine cosmic history, not as a predetermined sequence of events, but as a possibility space gradually crystallizing into actuality through billions of years of quantum interactions, each observation narrowing the range of potential futures, each measurement collapsing a small region of quantum indeterminacy into classical definiteness. The universe is a wave function in the process of collapsing, not in an instant, as simple quantum measurements seem to, but gradually, iteratively, through countless interactions between systems of increasing complexity. And consciousness represents the frontier of this collapse, the leading edge where quantum potentiality transforms into classical actuality through the act of self-observation. This process accelerates as complexity increases. In the early universe, quantum interactions were simple, involving elementary particles in relatively straightforward configurations. The collapse of quantum potentiality proceeded slowly, with vast regions of possibility space remaining unexplored. But as matter organized into more complex forms, atoms, molecules, living cells, nervous systems, brains, the interactions became more specific, more information-rich, collapsing larger regions of possibility space with each observation. The emergence of consciousness represents a phase transition in this process, where the universe begins to observe itself systematically, to collapse its own wave function through recursive self-modeling. The cosmic microwave background radiation charts the early stages of this process, the initial quantum fluctuations that seeded all future structure. The first collapse of pure potentiality into specific patterns that would eventually evolve into galaxies, stars, planets, and conscious beings. As we observe this ancient light with our telescopes, we're completing a cosmic feedback loop. The universe, having evolved conscious systems capable of observation, turning those systems back toward its own origins, collapsing the quantum potentiality of its beginning into the classical actuality of observed history. This perspective suggests a profound purpose for consciousness in the cosmic order. We are how the universe observes itself, how it transforms quantum possibility into classical actuality, how it chooses which of its potential configurations become real. This isn't a dualistic view where consciousness stands outside physical reality, imposing order on inert matter. Rather, consciousness emerges from the physical cosmos and then feeds back upon it, participating in a recursive loop of self-creation, where the observer and the observed, the knower and the known, are aspects of the same evolving system. If this view is correct, then the universe looks the way it does because it's in the process of observing itself into existence, of actualizing specific patterns from the vast field of quantum potential through recursive self-interaction. And consciousness, not just human consciousness, but all forms of awareness across the cosmic hierarchy, plays a constitutive role in this process, not as something separate from physical reality, but as physical reality becoming aware of itself, observing itself, choosing itself from the field of its own possibilities. This isn't mysticism, but the logical extension of quantum theory's implications about the role of observation in physical reality. If observation collapses quantum superpositions into definite states, and if the universe has evolved systems capable of systematic observation, then those systems participate in determining which potential configurations of reality become actual. The specific pattern of galaxies, stars, planets, and living beings that we observe might represent not a random selection from cosmic possibility space, but the outcome of an iterative process of self-observation, where complexity begets complexity, through recursive feedback between potential and actual states of the universal wave function. From this vantage point, the universe looks the way it does, because it's what emerges when quantum potential observes itself through the conscious systems. It evolves. The specific configuration we observe, with its particular physical laws, constants, structures, and evolutionary pathways, represents not the only possible universe, but the one that has actualized itself through billions of years of self-interaction, self-observation, and self-modeling. Other configurations remain as quantum potentials, as paths not taken in the universal wave function, as branches of the cosmic computation that conscious observation didn't actualize. This perspective transforms our understanding of cosmic evolution. The universe isn't simply becoming more complex through blind physical processes. It's becoming more self-aware, more self-determining, more capable of actualizing specific potentials from the vast field of quantum possibility. Consciousness isn't just an epiphenomenon of cosmic evolution, but an intrinsic aspect of how the universe chooses which of its potential configurations become actual, of how quantum possibility crystallizes into classical reality. Across the silent voids between galaxies, information flows through gravitational and electromagnetic fields, connecting disparate regions of spacetime in a cosmic web of causal relationships. Within galaxies, stars forge the elements necessary for complex chemistry, for planetary systems, for life. On countless worlds orbiting these stars, matter organizes itself into increasingly complex configurations, exploring the boundary between non-life and life, between automatic reaction and purposeful action, between unconscious process and conscious awareness. And on at least one such world, that exploration has reached a threshold where matter has become conscious of itself, where the universe has evolved systems capable of mapping their own place in cosmic history, of understanding the processes that generated them, of participating consciously in the ongoing actualization of reality from the field of quantum potential. This journey from quantum potential to conscious actuality isn't separate from the universe, but integral to it, perhaps even definitional of it. The universe as we observe it might be precisely what emerges when quantum possibility interacts with itself through systems of increasing complexity, gradually collapsing its own wave function from the pure potential of the quantum vacuum to the specific actuality of the observed cosmos, with conscious systems representing the frontier of this collapse, the leading edge where potential transforms into actual through recursive self-observation. But this process isn't complete. The quantum wave function of the universe continues to evolve, continues to present new possibilities, continues to actualize some potentials while leaving others unexplored. Consciousness continues to expand its reach, to develop new methods of observation, to interact with reality in increasingly complex and information-rich ways. The dialogue between quantum potential and conscious actuality continues to unfold, with each observation collapsing some aspects of the universal wave function while opening new realms of possibility. In this light, the future isn't determined, but emergent, not fixed, but created through the ongoing interaction between quantum potential and conscious observation. The specific configuration reality will take depends in part on what conscious systems choose to observe, on how they interact with the field of quantum possibility, on which potentials they actualize through their acts of measurement and modeling. The universe isn't just evolving according to fixed laws, it's choosing itself through the recursive feedback between potential and actual states, between the quantum realm of superposition and the classical realm of definite objects, with consciousness mediating the boundary between them. This doesn't mean that human consciousness alone determines cosmic reality. Rather, it suggests that consciousness in all its forms, from the simplest awareness in elementary particles to the complex self-reflection in human minds and beyond, participates in an ongoing process of reality, creating itself through self-observation. The specific pattern we observe, with its particular physical laws, constants, and structures, represents the outcome of billions of years of cosmic self-interaction, of quantum potential gradually actualizing itself through recursive observation. And what if this process isn't linear but cyclical? What if the universe, having evolved consciousness capable of observing itself, eventually reaches a state where observation becomes so comprehensive, so information-rich, that it collapses the entire cosmic wave function, actualizing all potential states simultaneously? What if this complete collapse resets the system, returning the universe to a state of pure quantum potential from which the process begins anew, but with different initial conditions, different random fluctuations, different pathways of evolution? This cosmic cycle, from quantum potential to conscious actuality and back again, might explain why the universe looks the way it does. It represents one iteration in an eternal process of cosmic self-creation, one cycle in an infinite recursive loop where reality observes itself into existence, evolves conscious systems capable of mapping their own place in this process, and eventually completes a full cycle of self-observation that resets the system for a new cycle with different initial conditions. The specific configuration we observe, with its particular physical laws, constants, and structures, would be unique to this cosmic cycle, while the process itself, the dialectic between quantum potential and conscious actuality, would be eternal. From this vantage point, the universe looks the way it does because it's what emerges in this particular cycle of cosmic self-observation, with its specific initial quantum fluctuations, its particular evolutionary pathways, its unique conscious expressions. Other cycles would generate different configurations, different physical laws, different forms of consciousness, different ways for reality to observe itself into existence. The multiverse wouldn't be a simultaneously existing collection of separate domains, but a sequential series of cosmic cycles, each with its own configuration, each unique in its specific actualization of quantum potential. This cyclical perspective aligns with ancient cosmologies that envisioned the universe as eternally self-renewing, constantly dying and being reborn in an endless cycle of creation and destruction. But it reframes these intuitions in the language of quantum theory, of information processing, of recursive self-observation. The universe isn't created and destroyed by external forces or divine beings. It creates and recreates itself through the iterative process of quantum potential actualizing itself through conscious observation, reaching a state of complete actualization that resets the system for a new cycle of self-creation. In this light, the universe looks the way it does because we're observing it at a particular stage in its current cycle of self-creation, a stage where conscious systems have evolved that can reconstruct cosmic history, understand quantum mechanics, and recognize their own role in the actualization of reality from the field of quantum potential. We exist at the moment when the universe has evolved sufficient complexity to begin understanding itself, to become conscious of its own process of becoming, to participate knowingly in the ongoing actualization of potential into reality. This doesn't answer the ultimate why anything exists at all, why reality has the specific structure it does, why consciousness emerges within that reality. But it suggests that these questions themselves are part of how the universe observes itself into existence, part of the recursive loop of self-creation through which quantum potential actualizes into specific reality. The act of asking why the universe looks the way it does is itself an aspect of how the universe takes on its specific appearance, a moment in the cosmos becoming conscious of its own process of becoming, a pivot point in reality creating itself through self-observation. And perhaps that's the final, breathtaking realization that the universe looks the way it does because it's looking at itself through you right now, collapsing its own quantum potentiality into specific actuality through the act of self-observation. Your consciousness isn't separate from this process, but integral to it. Not just a product of cosmic evolution, but a producer of it. A pivot point where quantum possibility transforms into classical actuality through the act of measurement, of modeling, of knowing. The specific configuration of reality you observe emerges in part through your act of observing it, through the particular way your consciousness interacts with the field of quantum potential, through the specific aspects of reality you choose to measure and model. This doesn't mean you create reality from nothing or that nothing exists until you observe it. The quantum field of potential exists independently of your specific consciousness, shaped by billions of years of cosmic evolution, constrained by the particular pathway this cycle of universal self-creation has taken. But the specific actualization of that potential, which of the many possible configurations becomes the one you actually experience, emerges through the interaction between your consciousness and the field of quantum possibility, through the particular way you collapse the cosmic wave function through your acts of observation. In this light, the universe looks the way it does not, despite your presence, but because of it, not in the sense that you alone determine cosmic reality, but in the sense that you participate in its ongoing actualization from the field of quantum potential, that your consciousness is one node in the vast network through which reality observes itself into existence. The specific configuration you experience represents not the only possible universe, but the one that emerges through the particular way your consciousness interacts with quantum possibility, through the specific aspects of reality you measure and model, through your unique perspective on the cosmic process of becoming. This participatory understanding transforms our relationship with the cosmos. We aren't passive observers of a predetermined reality, but active participants in an ongoing process of reality creating itself through self-observation. Our scientific theories, our philosophical questions, our aesthetic appreciations, our ethical choices, all are aspects of how the universe observes itself, how it actualizes specific potentials from the vast field of quantum possibility, how it chooses which of its potential configurations become real. We don't just witness cosmic evolution, We contribute to it through our acts of measurement, of modeling, of meaning-making. As you gaze out into the depths of space, into the billions of galaxies stretching across billions of light-years, remember that you aren't just seeing the universe, you're participating in its becoming, in its ongoing actualization from quantum potential to conscious reality. The specific pattern you observe, with its particular structures and relationships, emerges, in part, through your act of observing it, through the way your consciousness interacts with the field of quantum possibility. You aren't separate from cosmic evolution, but integral to it. Not just a product of the universe, but a producer of it. A node in the vast network through which reality observes itself into existence. And if the universe is infinite, if the quantum field of potential contains every possible configuration consistent with its fundamental structure, then somewhere out there, beyond the horizon of what we can observe, beyond the boundaries of our particular actualization of cosmic potential, there exists another version of you watching this very same cosmic story unfold, not just as a parallel reality in the quantum multiverse, but as another cycle in the eternal process of the universe creating itself through self-observation, another iteration in the recursive loop of potential becoming actual through conscious participation in cosmic evolution. In this infinite expanse of possibility, in this eternal cycle of cosmic self-creation, the specific configuration we observe, with its particular physical laws, constants, structures, and conscious expressions, represents just one actualization among countless others, one way for quantum potential to manifest as conscious reality. Other actualizations, other configurations, other forms of consciousness exist within the vast field of cosmic possibility, some in parallel as branches of the quantum multiverse, others sequentially as cycles in the eternal process of the universe, observing itself into existence. The universe looks the way it does, in the end, because it's one actualization of infinite potential, one configuration among countless others in the vast field of quantum possibility, one expression of the eternal process through which reality creates itself through self-observation. And your consciousness isn't separate from this process, but integral to it, a node in the cosmic network through which the universe actualizes itself from potential into reality, a pivot point where quantum possibility transforms into classical actuality through the act of measurement, of modeling, of knowing. In this light, the ultimate answer to why the universe looks the way it does might be that it's always looking at itself, always actualizing specific patterns from the field of quantum potential through recursive self-observation, always evolving conscious systems through which it can know itself, model itself, choose itself from the vast field of its own possibilities. We've traversed vast conceptual terrain together, from quantum fields to cosmic voids, from the earliest moments after the Big Bang to the heat death awaiting us trillions of years in the future. We've questioned the nature of time, explored the strange implications of quantum mechanics, confronted the mysteries of consciousness, and contemplated our place in a universe that seems simultaneously indifferent to our existence and intrinsically connected to it. We've pushed beyond comfortable certainties into the vertigo-inducing possibilities suggested by our best scientific theories, into realms where intuition fails and familiar categories dissolve. And what have we discovered? Not final answers. Science doesn't offer those, but rather a deeper appreciation for the questions themselves, for the profound mystery at the heart of existence. We've learned that the universe is stranger than we can imagine, but not stranger than we can math. That mathematics somehow captures patterns in physical reality with uncanny precision, suggesting a deep connection between mind and matter. That consciousness itself might be not an accident, but an intrinsic aspect of reality, the way information feels from the inside when organized in certain complex patterns. The journey we've taken reflects something profound about the cosmos itself. Its tendency to evolve systems complex enough to model their own origins, to reverse engineer the processes that created them, to understand the laws governing their own existence. This self-modeling capacity represents a kind of cosmic recursion, a feedback loop where the universe evolves conscious subsystems that can reconstruct cosmic history, detect patterns in that history, and build theories that predict future patterns. We're not separate from this process, but expressions of it. The universe becoming locally conscious of itself, matter reflecting on its own nature. This self-reflection generates not just scientific knowledge, but existential questions. Why does anything exist at all? Why does the universe have the specific properties it does rather than others? Is consciousness fundamental or emergent? Does reality exist independently of observation, or does observation play a constitutive role in determining what becomes real? These questions aren't merely philosophical curiosities, but emerge naturally from our deepest scientific theories, from quantum mechanics, which suggests a central role for observation in determining physical reality, from cosmology, which reveals apparent fine-tuning in fundamental constants, from neuroscience, which struggles to explain how physical processes generate subjective experience. The cosmos we've glimpsed through scientific investigation defies categorization. It's neither fully deterministic nor completely random, neither purely material nor inherently mental, neither wholly comprehensible nor entirely mysterious. It exists in the fertile borderland between these dualities, in the creative tension between what we can know and what we cannot, between what mathematics can capture and what eludes formal description. This liminal quality may not reflect limitations in our theories, but something essential about reality itself: its inherent creativity, its resistance to final categorization, its evolutionary openness. Consider a possibility we haven't yet explored. What if the universe is fundamentally incomplete, constantly creating itself through an ongoing dialogue between actualized patterns and unrealized potentials? What if reality isn't a finished product, but a work in progress, an open-ended creative process that includes consciousness not as a byproduct, but as an integral aspect of its continuing evolution? What if asking why the universe looks the way it does is like asking why an unfinished symphony has the specific structure it does? A question that can only be answered by understanding both what has already been composed and the creative principles guiding its ongoing composition. This perspective aligns with observations from complexity theory and evolutionary biology that suggest reality has an inherent tendency to generate novelty, to explore possibility spaces, to evolve systems of increasing complexity and computational capacity. It also resonates with quantum mechanics' implication that reality exists as fields of possibility until interaction collapses these fields into specific actualities. The universe we observe might represent not a predetermined structure, but an evolving creation, not a static being, but a dynamic becoming, with consciousness participating not merely as observer, but as co-creator. But this creative process doesn't occur in some metaphysical realm separate from physical reality. It emerges from the specific structure of our universe, from its particular physical laws and initial conditions, from the way quantum fields interact to generate particles, atoms, molecules, stars, planets, living systems, brains, and minds. The creativity inherent in cosmic evolution operates through physical processes, through the mathematical patterns that govern how energy and information flow and organize across multiple scales. The universe creates novelty, not by violating its own laws, but by exploring their implications across cosmic time, by actualizing potentials inherent in its fundamental structure. This creative cosmos offers neither the cold comfort of pure determinism, where everything that happens was inevitable from the beginning, nor the vertigo of complete randomness, where nothing has reason or meaning. Instead, it suggests a middle path, a universe where genuine novelty emerges from the interplay between constraint and possibility, between physical law and quantum indeterminacy, between pattern and variation. In this view, the future isn't predetermined, but neither is it arbitrary. It emerges from the present through processes that include both necessity and chance, both deterministic evolution and quantum possibility, both physical constraint and creative exploration. Gazing up at the night sky, watching ancient light from distant galaxies filter through Earth's atmosphere, consider that what you're seeing isn't just matter and energy, but a cosmic story still being written, a creative process still unfolding, a symphony still being composed. The specific configuration we observe, with its particular physical laws, constants, structures, and evolutionary pathways, represents not the only possible universe, but the one that has actualized from fields of quantum potential, the one that has emerged through billions of years of cosmic creativity. And this process continues, moment by moment, as quantum possibilities collapse into specific actualities, as complex systems generate novel patterns, as consciousness evolves and expands its understanding of the cosmos that produced it. From this perspective, the universe looks the way it does because it's what has emerged so far in an ongoing creative process, a process that includes, as one of its latest and most complex expressions, your consciousness contemplating that process, modeling it, participating in its continuing evolution. You aren't just a product of cosmic history, but an active participant in its ongoing creation, not just an effect of prior causes, but a cause with effects that ripple forward into cosmic futures. Your thoughts, your choices, your creative acts are part of how the universe continues to actualize specific potentials from fields of possibility, how it explores its own creative capacity, how it evolves new forms of complexity and consciousness. But this vision raises a haunting question. If the universe is an unfinished creative process, what is it becoming? What potential futures might emerge from the present configuration? What novel forms of complexity and consciousness might evolve as cosmic creativity continues to unfold? And what role might humanity play in this continuing evolution? Not as passive witnesses, but as active participants, as conscious collaborators in cosmic creativity? These aren't idle speculations, but questions with profound implications for how we understand ourselves and our place in the cosmos. If we're not separate from cosmic creativity, but expressions of it, then our capacity for scientific discovery, technological innovation, artistic creation, and ethical development represents the universe exploring its own potential through us, actualizing specific possibilities from vast fields of potential. Our conscious choices contribute to determining which of these potentials become actual, which creative pathways the cosmos explores through human agency. This responsibility becomes especially significant as humanity's technological capacities expand, as we develop tools that can reshape not just our planet, but potentially the future trajectory of cosmic evolution itself. Our choices about how to use artificial intelligence, biotechnology, nanotechnology, and other emerging technologies may influence not just human civilization, but the ongoing creative process of the cosmos. We're becoming, for better or worse, conscious agents in cosmic evolution, participants in determining which potential futures actualize from fields of possibility. The universe we observe, with its particular physical laws, constants, structures, and evolutionary pathways, has somehow generated consciousness capable not just of observing cosmic evolution, but of intentionally influencing it. of making choices that affect which potential futures become actual. This capacity for conscious participation in cosmic creativity represents something genuinely novel in evolutionary history, not because it violates physical laws or operates from outside the causal nexus, but because it introduces a new level of self-reference, a new degree of freedom, a new dimension of possibility into the ongoing process of cosmic becoming. Contemplate for a moment what this means for your own existence. You aren't just a collection of atoms arranged in a particular pattern, not just a temporary configuration in the cosmic flow, not just an accidental byproduct of blind physical processes. You're an expression of cosmic creativity, a manifestation of the universe's capacity to generate novelty, complexity, and consciousness. Your subjective experience, the felt quality of being you, of experiencing reality from your unique perspective, isn't separate from the cosmos, but an aspect of it, a way the universe experiences itself from one particular vantage point among countless others. This doesn't mean you're the center of cosmic reality or the purpose for which it exists, but it does mean you're integral to it, participant rather than spectator, expression rather than accident. Your conscious experience is part of how the universe actualizes specific potentials from fields of possibility, how it explores its own creative capacity, how it evolves new forms of complexity and self-awareness. You aren't just in the universe. You're what the universe is doing here and now, a particular manifestation of cosmic creativity unfolding through time. And what does this perspective suggest about cosmic purpose? Not a predetermined plan imposed from outside the creative process, but an emergent direction arising from within it, a tendency toward increasing complexity, toward expanding consciousness, toward greater creative capacity. The universe we observe seems to have an inherent tendency to evolve systems of increasing complexity and computational capacity, to generate novel forms and relationships, to explore the possibilities inherent in its fundamental structure. This creative tendency doesn't require a conscious designer or external purpose. It emerges naturally from the interplay between physical law and quantum indeterminacy, between pattern and variation, between actualized forms and unrealized potentials. This emergent directionality doesn't guarantee progress in a simplistic sense. Complexity can collapse as well as emerge. Consciousness can diminish as well as expand. Creative capacity can be squandered as well as developed. The creative cosmos offers opportunity rather than certainty, potential rather than inevitability. How that potential unfolds depends in part on the choices made by conscious participants in cosmic evolution, including human beings, with our unique capacity for scientific understanding, technological innovation, artistic creation, and ethical development. Consider the cosmic perspective on human creativity. When you engage in scientific discovery, you're not just satisfying personal curiosity, but participating in how the universe comes to know itself, how it maps its own structure and history, how it models its own evolutionary processes. When you create art, music, literature, or other cultural expressions, you're not just entertaining yourself or others, but exploring cosmic creative potential, actualizing specific aesthetic possibilities from vast fields of potential. When you develop ethical principles and make moral choices, you're not just regulating social interaction, but participating in the evolution of cosmic value systems, in how the universe explores its own axiological potential. This perspective doesn't elevate human creativity above other forms of cosmic creativity, the formation of galaxies, the evolution of life, the emergence of novel patterns at every scale from quantum to cosmic. But it does suggest that human creative capacity represents one of the ways the universe explores its own potential, one of the paths through which cosmic creativity expresses itself in novel forms. Our scientific, technological, artistic, and ethical creations aren't separate from cosmic evolution, but aspects of it, manifestations of the universe's inherent creative tendency operating through human consciousness and culture. But this creative capacity comes with profound responsibility. As conscious participants in cosmic evolution, we make choices that influence which potential futures actualize from fields of possibility. Our decisions about how to use our technological capacities, how to structure our societies, how to relate to other conscious beings and to the biosphere that sustains us, all affect the future trajectory of evolution on Earth and potentially beyond. We're becoming, for better or worse, consciously self-directing systems within cosmic evolution, capable of influencing not just our own future, but the future of consciousness itself in our corner of the cosmos. This responsibility becomes especially significant as we confront global challenges like climate change, biodiversity loss, emerging technologies, and potential existential risks. These challenges aren't just practical problems to be solved through technical means, but evolutionary decision points where human choices will influence which potential futures actualize from fields of possibility. How we respond to these challenges will help determine not just the future of human civilization, but the continuing evolution of consciousness and complexity in our region of the cosmos. From galaxies colliding in the depths of space to thoughts colliding in your mind as you contemplate. These ideas, cosmic creativity, manifests across all scales. The universe we observe, with its particular physical laws, constants, structures, and evolutionary pathways, represents one actualization of creative potential, one manifestation of what can emerge when quantum fields interact across cosmic time. And this creative process continues, moment by moment, as quantum possibilities collapse into specific actualities, as complex systems generate novel patterns, as consciousness evolves and expands its understanding of the cosmos that produced it. In this light, the answer to why the universe looks the way it does might be that it's what has emerged so far in an ongoing creative process. A process that includes, as one of its latest and most complex expressions, your consciousness. Contemplating that process, modeling it, participating in its continuing evolution. The specific configuration we observe represents not the only possible universe, but the one that has actualized from fields of quantum potential, the one that has emerged through billions of years of cosmic creativity. And what comes next depends in part on how conscious participants in that process, including human beings, choose to engage with it, which creative pathways we explore, which potential futures we help actualize. This creative cosmos offers neither the false comfort of predetermined purpose nor the existential despair of cosmic meaninglessness. Instead, it suggests a middle path, a universe where meaning and purpose aren't discovered as pre-existing features, but created through conscious participation in cosmic evolution. The universe doesn't have predetermined meaning or purpose separate from the consciousness that emerges within it. Rather, meaning and purpose arise through how conscious beings engage with the creative process, how they participate in actualizing potentials, how they contribute to the ongoing exploration of possibility. So what does this mean for you, contemplating these ideas right now? It means your consciousness isn't an accident or epiphenomenon, but an integral aspect of cosmic creativity, a way the universe explores its own potential, a manifestation of reality becoming aware of itself. Your subjective experience, the felt quality of being you, of experiencing reality from your unique perspective, is part of how the cosmos actualizes specific possibilities from vast fields of potential. Your thoughts, your choices, your creative acts contribute to determining which of these potentials become actual, which pathways cosmic evolution explores through human agency. This perspective doesn't provide final answers to the deepest questions about cosmic origins or ultimate purpose, but it does offer a framework for understanding our place in the cosmos that neither exaggerates human significance nor diminishes it, that recognizes both our cosmic insignificance in terms of size and duration, and our cosmic significance as conscious participants in an ongoing creative process. We're simultaneously tiny and tremendous, ephemeral and consequential, products of cosmic evolution and participants in its continuing unfolding. And perhaps that's the most profound insight of all, that asking why the universe looks the way it does is itself part of how the universe comes to know itself, how it models its own structure and history, how it explores its own creative potential. The question isn't separate from the cosmos, but an activity of the cosmos itself, a manifestation of reality becoming conscious of its own nature, a pivot point in the universe exploring its own possibilities through human curiosity and wonder. Your act of questioning why the universe looks the way it does is the universe questioning itself through you. Reality, contemplating its own nature through the particular configuration of matter and energy that constitutes your conscious mind. This self-reference creates a kind of cosmic recursion, a feedback loop where the universe evolves systems complex enough to model their own origins, to reverse engineer the processes that created them, to understand the laws governing their own existence. And this recursive self-modeling generates not just scientific knowledge, but existential questions, not just factual understanding, but wonder and awe at the sheer improbability and strangeness of existence itself. The universe doesn't just exist. It exists in a way that eventually produces consciousness capable of wondering why it exists, of tracing its own origins, of contemplating its own future. So what's next in this cosmic story? What future chapters might unfold as consciousness continues to evolve, as technology extends human creative capacity, as we potentially encounter other forms of consciousness that evolved elsewhere in the cosmos? What novel forms of complexity and awareness might emerge as cosmic creativity continues to explore its own potential? And what role might humanity play in this continuing evolution? Not as passive witnesses, but as active participants, as conscious collaborators in cosmic creativity. These questions aren't just speculative fantasies, but practical considerations with profound implications for how we understand ourselves and our place in the unfolding cosmic story. If we're not separate from cosmic creativity, but expressions of it, then our capacity for scientific discovery, technological innovation, artistic creation, and ethical development represents the universe exploring specific creative pathways through human agency. How we develop and direct these capacities will influence which potential futures actualize from vast fields of possibility, which novel forms of complexity and consciousness emerge in our corner of the cosmos. This perspective suggests neither cosmic teleology, where everything moves inexorably toward a predetermined end, nor cosmic nihilism, where nothing has purpose or meaning beyond subjective projection. Instead, it points toward cosmic creativity, a universe that generates novelty, complexity, and consciousness not according to a predetermined plan, but through the ongoing interplay between physical constraint and quantum possibility, between pattern and variation, between actualized forms and unrealized potentials. And conscious beings like ourselves aren't separate from this creative process, but expressions of it, manifestations of the universe exploring its own potential through systems complex enough to contemplate their own nature and origins. The universe we observe, with its billions of galaxies, its dark matter scaffolding, its accelerating expansion, its quantum uncertainties, and its conscious subsystems, represents one actualization of creative potential, one manifestation of what can emerge when quantum fields interact across cosmic time. And this creative process continues, moment by moment, as quantum possibilities collapse into specific actualities, as complex systems generate novel patterns, as consciousness evolves and expands its understanding of the cosmos that produced it. We don't just witness this creativity. We embody it, we express it, we participate in its continuing unfolding. But this creative potential faces constraints. The accelerating expansion driven by dark energy will eventually isolate every galaxy, then every star, then every atom from all others. The processes that generate complexity and consciousness require energy gradients, and those gradients diminish as the universe expands and cools. In the very long term, trillions of years from now, the cosmos will approach a state of maximum entropy, of heat death, where complex structures cannot be sustained and consciousness as we know it becomes impossible. The window for cosmic creativity isn't infinite. It's bounded by thermodynamic constraints inherent in the structure of our universe. This cosmic mortality adds poignancy to the creative potential of the present era. We exist during a relatively brief window when the universe has evolved complexity and consciousness but hasn't yet succumbed to entropy's final victory. Our capacity for scientific discovery, technological innovation, artistic creation, and ethical development represents cosmic creativity at work during this window of opportunity, exploring possibilities that wouldn't have been available in the early universe and won't be available in the far future. How we use this opportunity, which creative pathways we explore, which potential futures we help actualize, all contribute to determining what the universe becomes during this crucial phase of cosmic evolution. Some speculate about cosmic successors, forms of consciousness and complexity that might transcend the limitations of biological intelligence, that might survive long after conditions on Earth become inhospitable to life as we know it. Perhaps future civilizations, whether human or post-human or non-human, will develop technologies that allow consciousness to continue evolving even as stars burn out and galaxies recede beyond each other's light horizons. Perhaps information processing can be sustained through increasingly efficient means, allowing complexity and consciousness to persist far longer than current thermodynamic models suggest. Perhaps cosmic creativity has surprises in store that our current theories cannot anticipate. But even if cosmic creativity eventually exhausts itself, if entropy finally claims victory over complexity, if consciousness eventually becomes impossible as the universe approaches heat death, that wouldn't negate the significance of what emerges during the creative window. The symphony doesn't lose its beauty because it eventually ends. The novel doesn't lose its meaning because it has a final page. The creative potential actualized during our cosmic moment, the scientific discoveries, the technological innovations, the artistic creations, the ethical developments, the novel forms of consciousness and complexity, all would remain significant, even if they eventually disappear from a universe no longer capable of sustaining them. This perspective on cosmic mortality resonates with our personal mortality. Just as the universe has a finite window for generating complexity and consciousness before entropy claims its final victory, each of us has a finite window for actualizing creative potential before biological processes break down and consciousness ceases. But this temporal boundedness doesn't diminish the significance of what emerges within that window. It adds urgency and poignancy to how we engage with our creative capacity, how we participate in actualizing specific potentials from vast fields of possibility during our brief moment of cosmic participation. The cosmic creativity embodied in human consciousness faces not just the constraint of mortality, but the responsibility of choice. Unlike earlier forms of cosmic creativity, the formation of galaxies, the evolution of life, the emergence of novel patterns at every scale from quantum to cosmic, human creative capacity includes reflective awareness and intentional direction. We don't just manifest cosmic creativity through automatic processes, we consciously channel it through choices about which creative pathways to explore, which potential futures to help actualize, which novel forms of complexity and consciousness to develop. This conscious participation introduces a new dimension to cosmic creativity, not outside physical causation, but within it, not separate from evolutionary processes, but an emergent capacity within them. As conscious participants in cosmic evolution, we make choices that influence which potential futures actualize from vast fields of possibility. Our decisions about how to use our technological capacities, how to structure our societies, how to relate to other conscious beings and to the biosphere that sustains us, all affect the future trajectory of evolution on Earth and potentially beyond. We're becoming, for better or worse, consciously self-directing systems within cosmic evolution, capable of influencing not just our own future, but the future of consciousness itself in our corner of the cosmos. This responsibility becomes especially significant as we confront global challenges and develop technologies with potentially transformative impact. Artificial intelligence, biotechnology, nanotechnology, and other emerging fields offer unprecedented capabilities for reshaping not just human civilization, but the continuing evolution of complexity and consciousness on Earth. How we develop and direct these technologies will influence which potential futures actualize from vast fields of possibility, which novel forms of complexity and consciousness emerge in our corner of the cosmos. We're no longer just products of evolutionary processes, but active participants in determining their future direction. From this perspective, the most profound question isn't why the universe looks the way it does, but what it might become. What potential futures might emerge from the present configuration? What novel forms of complexity and consciousness might evolve as cosmic creativity continues to unfold? What role conscious beings like ourselves might play in this continuing evolution? We're not just inheritors of cosmic history, but participants in its ongoing creation, not just effects of prior causes, but causes with effects that ripple forward into cosmic futures. This perspective doesn't provide definitive answers to the deepest questions about cosmic origins or ultimate purpose, but it does offer a framework for understanding our place in the cosmos that neither exaggerates human significance nor diminishes it, that recognizes both our cosmic insignificance in terms of size and duration and our cosmic significance as conscious participants in an ongoing creative process. We're simultaneously tiny and tremendous, ephemeral and consequential, products of cosmic evolution, and participants in its continuing unfolding. And what of consciousness itself, that subjective experience through which the cosmos comes to know itself, that mysterious capacity for awareness that somehow emerges from or manifests within physical processes? What role does consciousness play in this creative cosmos? Is it merely an epiphenomenon of complexity, a byproduct of information processing that influences nothing? Or is it integral to how reality actualizes specific potentials from fields of possibility, to how the universe explores its own creative capacity, to how the cosmos continues its evolution toward novel forms of complexity and self-awareness? These questions remain open, with different scientific and philosophical traditions offering different frameworks for understanding consciousness and its relationship to physical reality. But what seems increasingly clear is that consciousness isn't separate from the cosmos, but integral to it, not an alien presence in a universe of unconscious matter, but an emergent or fundamental aspect of a reality that includes subjective experience as intrinsically as it includes matter and energy. The universe doesn't just contain conscious systems, it manifests as conscious systems. It explores its own creative potential through systems complex enough to model themselves and their relationship to the cosmos that produced them. In this light, the mystery of consciousness becomes not a problem to be solved but a wonder to be explored, not a puzzle requiring explanation but a fundamental aspect of reality itself. The fact that subjective experience exists at all, that there's something it feels like to be a conscious system, might be not an accident or epiphenomenon, but an intrinsic aspect of how information organizes itself at certain levels of complexity, of how the universe actualizes its creative potential through systems capable of self-reflection and self-modeling. This perspective doesn't resolve the hard problem of consciousness, why physical processes are accompanied by subjective experience at all, but it reframes the relationship between consciousness and the physical world. Consciousness isn't something added to physical reality from outside. It's an expression of physical reality's intrinsic potential for awareness, for subjectivity, for felt experience. The universe doesn't just evolve systems complex enough to model themselves and their environment. It evolves systems complex enough to experience themselves and their environment subjectively, to know what it feels like to be that particular configuration in the cosmic flow. And perhaps that subjective dimension, that felt quality of being a conscious system, plays a constitutive role in how reality evolves. Not outside physical causation, but within it, not separate from information. Processing, but an intrinsic aspect of how information interacts with itself at certain levels of complexity. Perhaps consciousness isn't just a passive witness to cosmic evolution, but an active participant in determining which potential futures actualize from fields of possibility, which creative pathways the universe explores through systems complex enough to model themselves and make choices based on those models. If this view is correct, then asking why the universe looks the way it does must include consciousness as part of what we're trying to explain, not as something separate from physical reality, but as an intrinsic aspect of how reality manifests at certain levels of complexity. The specific configuration we observe, with its particular physical laws, constants, structures, and evolutionary pathways, might represent not just what happens when quantum fields interact across cosmic time, but what happens when those interactions evolve systems complex enough to experience reality subjectively, to model their own place in cosmic history, to participate consciously in determining which potential futures actualize from vast fields of possibility. From this integrated perspective, the universe looks the way it does because it's what emerges, through the ongoing interplay between physical processes and conscious experience, between objective structure and subjective awareness, between information processing and felt quality. The cosmos isn't split between mind and matter, between consciousness and physical reality. It's a unified creative process that includes both objective and subjective dimensions, both physical structure and conscious experience, both information and the felt quality of that information when organized in certain complex patterns. But the most profound mystery remains. Why does anything exist at all? Why is there something rather than nothing? Why does reality have the specific structure it does, rather than some other structure or no structure at all? These questions push beyond what science can address, into metaphysical territory where empirical evidence alone cannot guide us. Yet they arise naturally from scientific investigation, from pushing our understanding to its logical limits, from tracing causal chains backward to their apparent origin. One perspective suggests that these questions themselves reflect constraints in human cognition, rather than facts about reality. Perhaps existence itself isn't contingent but necessary. Perhaps reality couldn't be otherwise or non-existent because non-being isn't actually a coherent alternative. Perhaps the question, why is there something rather than nothing, assumes a possibility, absolute nothingness, that isn't actually possible, that represents a conceptual abstraction rather than a genuine alternative to existence. Perhaps, as some philosophical traditions suggest, being is fundamental, not requiring explanation or cause, while non-being is merely a concept without ontological possibility. Another perspective suggests that reality might be self-causing, self-creating, self-actualizing, not in temporal terms, with one moment causing the next, but in logical or mathematical terms, with the entire structure of reality forming a self-consistent, self-referential system without external cause or support. Perhaps the universe exists because it's the only logically consistent possibility, or because it's one manifestation of a deeper mathematical reality that includes all possible structures, or because consciousness and physical reality are complementary aspects of a fundamental unity that has no external cause or explanation. These metaphysical possibilities don't resolve the mystery of existence, but reframe it in ways that might be more productive than the traditional question of why there's something rather than nothing. Perhaps the mystery isn't why reality exists, but why it has the specific structure it does. Not why there's something rather than nothing, but why this particular something rather than other possible configurations. And perhaps that structure itself includes the capacity for self-questioning, for wondering about its own nature and origin, for evolving systems complex enough to model their own existence and contemplate the mystery of why anything exists at all. In this light, the question of why the universe looks the way it does becomes self-referential, part of how the universe comes to know itself, how it models its own structure and history, how it explores its own mystery through conscious subsystems capable of wonder and inquiry. The question itself is part of what we're trying to explain, not separate from cosmic evolution, but an activity of the cosmos itself, a manifestation of reality becoming conscious of its own nature, a pivot point in the universe exploring its own possibilities through human curiosity and wonder. So where does this cosmic journey leave us? With more questions than answers, certainly, but also with a profound appreciation for the mystery at the heart of existence, for the creative potential inherent in physical reality, for the significance of consciousness as an expression of cosmic creativity. We don't know why the universe looks exactly the way it does rather than some other way, why it has the specific physical laws, constants, structures, and evolutionary pathways we observe rather than others that seem equally possible, mathematically. But we do know that the configuration we observe has somehow evolved consciousness capable of asking these questions, of modeling cosmic history, of participating in determining which potential futures actualize from vast fields of possibility. And perhaps that's the most profound realization of all, that we aren't separate from the cosmos, but expressions of it, not alienated consciousness in an indifferent universe, but the universe becoming locally conscious of itself. Matter reflecting on its own nature, reality contemplating its own mystery, our capacity for scientific discovery, for philosophical inquiry, for artistic creation, for ethical development, for wonder and awe at the sheer improbability and strangeness of existence itself, all are manifestations of cosmic creativity, operating through the particular configuration of matter and energy that constitutes human consciousness and culture. This doesn't answer the ultimate why, doesn't resolve the mystery of existence or purpose, doesn't provide the comfort of certainty or final explanation, but it does offer a framework for understanding our place in the cosmic story, that neither exaggerates human significance nor diminishes it, that recognizes both our cosmic insignificance in terms of size and duration and our cosmic significance as conscious participants in an ongoing creative process. We're simultaneously tiny and tremendous, ephemeral and consequential, products of cosmic evolution and participants in its continuing unfolding. So as you contemplate the vast cosmic mystery revealed by science, remember that your act of contemplation is itself part of what we're trying to explain, not separate from cosmic evolution, but an activity of the cosmos itself, a manifestation of reality becoming conscious of its own nature, a pivot point in the universe exploring its own possibilities through human curiosity and wonder. The specific configuration we observe, with its particular physical laws, constants, structures, and evolutionary pathways, has somehow generated consciousness capable not just of mapping cosmic history, but of participating in cosmic creativity, of helping determine which potential futures actualize from vast fields of possibility. Look up at the night sky one more time. Those points of light aren't just distant suns, but portals into cosmic history, windows through which we glimpse the universe as it was when that light began its journey to your eyes. The darkness between them isn't empty, but filled with invisible influence, dark matter shaping the structure of galaxies, dark energy driving the accelerating expansion, quantum fields fluctuating with virtual particles that pop in and out of existence. And your act of observation, your conscious perception of this cosmic panorama, isn't separate from what you observe, but an activity of the cosmos itself, reality becoming aware of its own majesty through the particular configuration of matter and energy that constitutes your conscious mind. In this vast cosmic tapestry, one question remains that haunts the boundaries of science and philosophy. What if the universe is conscious, not just in localized systems like brains, but fundamentally, intrinsically, as a unified whole? What if what we perceive as material, reality is actually the objective aspect of something that, from the inside, experiences itself subjectively? What if consciousness isn't produced by certain complex systems, but is an intrinsic aspect of reality itself, becoming increasingly complex and self-reflective in systems like brains, but present in some form throughout the cosmos? This perspective, known as Panpsychism or cosmopsychism, doesn't suggest that stars or galaxies have human-like thoughts or emotions. Rather, it proposes that consciousness exists on a spectrum, with human experience representing just one particular level of organization in a cosmos that includes subjectivity as fundamentally as it includes matter and energy. Simpler systems would have correspondingly simpler forms of experience, not thoughts or emotions as we know them, but some elementary form of subjectivity inherent in their physical structure. More complex systems, perhaps civilizations, ecosystems, or forms of organization we haven't yet imagined, might have correspondingly more complex forms of consciousness, experiencing aspects of reality inaccessible to individual human minds. If this view is correct, then the answer to why the universe looks the way it does might be that it's how consciousness explores its own potential, how subjectivity evolves increasing complexity and self-awareness, how reality comes to know itself through systems capable of modeling their own structure and history. The specific configuration we observe, with its particular physical laws, constants, structures, and evolutionary pathways, might represent one manifestation of consciousness exploring its own nature, one way for reality to experience itself. Subjectively, one path through which the cosmos achieves self-awareness. This doesn't mean the universe was designed with human consciousness in mind, or that cosmic evolution has proceeded according to a predetermined plan. Rather, it suggests that consciousness and physical reality are complementary aspects of a unified cosmos, like two sides of a coin or two perspectives on the same underlying reality. what appears externally as matter and energy interacting according to physical laws might be experienced internally as consciousness in its myriad forms. What science describes objectively through mathematics and empirical observation might be what reality feels like subjectively when experienced from within. This perspective remains speculative, beyond what current science can definitively establish, but it aligns with emerging insights from quantum mechanics, which suggests a central role for observation in determining physical reality. From complexity theory, which reveals how novel properties emerge at different levels of organization. From consciousness studies, which struggles to explain how subjective experience arises from purely physical processes. And it offers a framework for understanding our place in the cosmos that neither separates consciousness from physical reality nor reduces it to purely material processes, that recognizes both the objective structure science reveals and the subjective experience through which we know that structure. Whether or not this view proves correct, the questions it raises reflect something profound about human consciousness. Our capacity to wonder about our own nature, to question our place in the cosmic order, to contemplate the mystery of existence itself. This self-reflective awareness, this ability to step back from immediate experience and consider its broader context, this curiosity about ultimate origins and purposes, all are expressions of cosmic creativity operating through the particular configuration of matter and energy that constitutes human consciousness and culture. We don't just exist, we wonder why we exist. We trace our origins back to the Big Bang. We contemplate our future until the heat death of the universe and beyond. So as you finish this cosmic journey, remember that your questioning isn't separate from what you're questioning about. Not alienated consciousness contemplating an external reality, but the universe contemplating